Hello to everybody joining us at home. We are on board the Falcor 2 and we are at the El Quisco seep site on the Pacific coast of Chile today. We welcome everyone from home as they join us aboard here. We're just made it to the sea floor at a depth of about 400 meters, and we've already seen some exciting sights, some sharks and maybe bacterial mat on the sea floor. So we're doing a bit of a white balance here to make sure our cameras are set up to get our optimal imagery today, and then we'll start exploring. My name is Adam Skarke. I'm a professor of geology at Mississippi State University, and I'm one of the many members of the science team aboard the Falcor 2. And today we're going to start off our dive by testing out the SAGE methane sensor. That is a newly developed sensor that can detect methane on board our vehicle. We'll be making some transects to test it out, and that's important because we are at a seep site, and one of the primary gases we know are coming out of the sea floor to seep site is methane. So the sensor can help us understand that and do better science here and better understand the processes of these unique environments. Okay, those look like some bacterial mats likely, which are a very good indicator that we are at a site of gas seepage from the sea floor. And can you tell, is that a coral between the mats? That red object? Yeah, it looks like almost like a bubblegum coral, Paragorgia.
Oh, yep, and every time you see one that has that worm on it,
Yeah.
it's a symbiote.
It's a symbiont, that worm. Yeah, it lives in association with that coral.
Bivalve shells too.
Yeah, we see some bivalve shells, also a good indicator of a seep environment. One of the reasons we know these organisms are indicative of a seep environment is because they are part of a chemosynthetic ecosystem. That is an ecosystem where the basis of the food chain is not sunlight, but rather organisms, usually bacteria or archaea, that turn chemicals coming out of the seafloor into carbohydrates, and that serves as the base of the food chain through a process known as chemosynthesis. And they're endemic species to these environments, or species we typically find in these environments. And so some of these mats here we're seeing in bivalve shells are a good indicator that we're on a seep site.
We might already be getting a methane spike.
Oh,
Not a spike,
Or
but
elevated.
the baseline's up a couple of ppm as soon as we hit seafloor. So
oh, that's
there's
great.
methane around, just ambient.
That's great. Sounds like our methane sensor is detecting methane here, which is outstanding result already.
You know, it's this place.
Beginning of this dive, fantastic. Is that a rock? It's a carbonate rock? Oh, and is that a net on the seafloor?
Anthropogenic.
Could be anthropogenic. Yeah, it could be a net indicative of maybe fishing activities at these sites. Yeah, I'm not sure what that object is there. That looks like some perhaps marine debris as well.
No one's. Do we have any deers? Never been sure anyway.
Let's see what we have here. Looks like perhaps some more debris and maybe some bacterial mats ahead. And I don't think so. No.
It's almost like there couldn't be anything there. China. I'll bite it.
To provide a bit more context about these methane seeps, these are locations where, as I mentioned, gas is coming out of the seafloor, and usually this is produced in the seafloor amongst the sediments that compose the seafloor by organisms that consume organic material, and in that process of consuming it, produce methane and hydrogen sulfide, the two most common gases we tend to find in seep sites. And those are what feed these sites and sometimes provide energy. That looks like perhaps a carbonate rock. To the left there, there are organisms in these environments that, as part of their life cycle, bioprecipitate rock, carbonate rock, like what I believe what we're looking at right here. So that's called authogenic carbonate rock. It forms in place, and another great indicator of a seep environment. And I think we see around it some coral as well. And it looks like a little crab back there. Is that something, that fluid?
That doesn't look like shadow.
Doesn't look like a shadow. It's dark. It almost looks like brine. Or don't think that would be here, but so we're continuing to make our way south at this site. I think it's safe to say we're on a seep.
Yeah.
All indicators say that we have identified a methane seep here, which was our goal. And I think something I hadn't pointed out before is that there has never previously been a deep submergence observation of the site. So we've never had a remotely operated vehicle like Sebastian or a submersible or submarine at this site. to make observations. So we're among the first to be viewing this today as we explore this new site.
Yeah, good question.
Oh wow, that's cool.
It's like pretty flat though. Yeah, you're doing 10 years, yeah.
Would it be possible to head over to the high point there to our, a little bit to our left? It's part of our transit waypoint 2. Yep, that's the one.
He wants to go over it.
Oh, there's a squid. Very cool. Is that another shark? Sure looks like it. Oh, that's a cool shot. That little shrimp there, just waiting. And we're starting to make our way over to a slight high point, a bit of a mound that we detected in our overnight mapping in the area, just to check it out and see what's over here on our way to waypoint 2. Oh, there goes the squid. I believe that's a Humboldt squid. As I mentioned, this is some of the first exploration of the site that's taken place, and we know that nearby on the coastline of Chile there's a marine protected area.
RV Bridge, would you like me to move up to the waypoint?
On the El Quisco coast, and what we learn here could play a part in better understanding
Position.
and informing management of these deeper waters offshore. So this looks to be a carbonate rock outcrop. So it appears to be Some dense tube aggregations, what appears to be carbonate rock in this area, I think. Well, maybe that's just tubes. A lot of bivalve shells here. And quite a bit of marine debris as well. Wow, that's amazing.
No, so it's just waiting for when you're ready to see it.
Oh, Humboldt squid's gonna come right by.
Oh, yeah.
That's great. Look at that. Just saying hi.
Yeah, so Adam, we have our highest methane concentration so far right on top of this mound.
Yes.
So going up slowly, it's not spiking, but
Are those
it continues to go up.
So our SAGE instrument, our instrument that measures methane concentration in the water, is detecting by far the highest levels right over this mound feature, which suggests this may be the focus point of a seep. That certainly.
Bubbles.
What's that? Bubbles? Bubbles. There's a bubble stream. We have gas bubble stream coming out with our seep here. Fantastic. Fantastic. Thank you. There you can see the bubbles escaping the seafloor. So that's the gas I'm referring to, methane, perhaps some hydrogen sulfide escaping right around this mound feature here. And that's what's feeding this ecosystem we see here. This is very exciting. We have found what we were looking for.
So why'd you choose this position as your starting waypoint?
That's a really good question. So we chose this position as our starting waypoint based on a lot of mapping we did overnight. The Falcor 2 has a sonar system on it that can map the seafloor, and that tells us the shape of the seafloor. So for instance, we can see that there's a mound here, and that's a potential indicator that we're around a seep site. But also, that sonar can tell us essentially how hard and rough the seafloor is. It's something known as backscatter, and so the sonar can measure the seafloor hardness and roughness. And what we tend to find around methane seeps like this are the authogenic carbonate rocks, and that makes the seafloor a bit harder, and that can show up on our sonar. So today, before this dive, my colleagues and myself looked at the mapping data, and we selected sites that had really strong reflectivity, where that sonar, the sound pulse produced by the sonar, was bouncing off the seafloor, indicating a really hard seafloor relative to the other areas. And that is how we picked our waypoints today. And it looks like we made a good call. One thing that's a little bit unique about this site too is that it is likely around the oxygen minimum zone in the ocean, and that probably influences the type of organisms that live here. As you go down in the ocean from the surface, the amount of dissolved oxygen changes. That is, as you get deeper, you get farther away from the surface, and where all the organisms are that do photosynthesis, like phytoplankton, are producing oxygen. You get away from that, and you get to a zone of the least amount of oxygen, known as the oxygen minimum zone, and we expected that to be somewhere around here, doesn't it? And so that may be influencing the type of organisms we see at the seep as well. Wow, that's remarkable. There's crabs on there.
Yeah, Adam, we're getting an even larger spike. I'd say this is a spike.
Yeah, this is
in
now.
methane.
Yeah, our methane sensor is getting a spike here, which is probably no surprise. This is where we saw the bubbles come out of the seafloor. So we're getting sort of likely pure methane gas coming out of the seafloor here into the ocean.
Is that a relative measurement, or do you have actually a concentration?
Oh, and the Humboldt squid are hanging out.
So right now, Adam, we're getting from SAGE saying that 50 ppm of methane.
50 parts per million of methane. So very high concentrations of methane at this site.
Yeah, and what was our background, Scott?
8.
8.
Yeah, so we went from 8 parts per million to 50 parts per million of methane as we climb this feature here. So
That 8 is mostly the limit of detection on the instrument.
Right.
The true background is lower.
right, yeah. Yeah, so that 8 is just the lowest the instrument can measure. It may in fact be lower, but all that to say that we have a lot of methane concentrated in the water here. Clear indication of being on a methane seep. Really unique deep sea environment, and it'll be very exciting to explore this over the course of today.
So continue on.
Yeah, I think continue to waypoint 2, since we're testing out the methane sensor, moving off this feature and maybe seeing that concentration come down would be helpful to develop that.
Did you want to mark that on the map?
Yeah, let's put a mark
Yeah.
for, we've been marking observations for
Yeah, we
bubbles. back
mark
here.
bubbles. Yep.
And we can drop a waypoint to, do you need a pen?
Bubbles.
Yeah. Just note bubbles there.
Well, yeah, bubbles and
Bubbles and
mound, I guess. but
mound.
I don't know, but that, we were dislodging some of those bubbles. It didn't seem to be like an active bubble stream.
Was not continuous.
We didn't detect any bubbles in the acoustics last night, but maybe
Yeah.
the intermittentness of them, you have to be right over them when they're happening.
Yeah, my colleague Jeff makes a good point. The sonar system I mentioned earlier that we use to measure the reflectivity of the seafloor and find these harder areas is really good at detecting bubbles that come out of the seafloor in the water column. We oftentimes can see streams of bubbles traveling hundreds of meters up off the seafloor into the ocean water column, and the sonar is very good at picking that up. We didn't detect any of those last night, and that maybe is consistent with what we saw here today, that there was not a real continuous strong stream of bubbles, but nonetheless a few of them did come out there, showing quite a bit of gas in the sediment this location. Wow, these squid are everywhere. Fantastic.
Yeah, and as you might expect, as we come off that mound, it looks like the SAGE is starting to drop its methane concentration.
All right, so as we're coming away from the mound, you can see the seafloor is going back to more sediment, and that gets at that difference between the hard and the soft seafloor that we can see with the sonar and help us plan our dives. And we noticed that our methane sensor is also coming down as well, indicating that we're maybe moving away from a hot spot of gas discharge.
back online and then head over?
Let's get back online and head over. All right, so we're heading now towards waypoint 2, and we're gonna continue to observe the seafloor as we move and test our SAGE sensor. Oh, looks like we've got some more
No, that's the same all the way around.
oh, we're coming back over the mound. I got you. I see.
So Adam, do you think, this is right, and you can correct me, each time, everywhere you see those bacterial mats, there has to be at least some production, nothing at the mat
That-
to sustain the bacterial mat.
That's my understanding, is there likely has to be, anywhere you're seeing those mats, there's substantial methane in the sediment
Yeah.
underneath the seafloor that's providing that carbon to the seafloor here, and that's consistent. We also have another kind of sonar on the Falcor 2, the sub-bottom profiler, and that lets us look beneath the seafloor at the layered sediments underneath the seafloor. And it also can show us where there's gas amongst the sediments in the open space between the sediment grains. And we saw around this area a number of locations where there were sort of concentrated areas of gas within the sediment beneath the seafloor. And so we might expect that over an extended area there's gas making it to the seafloor here that would be source. Is that a line maybe? Anthropogenic? Yeah.
Probably
Fishing line, maybe a fishing long line or something like that.
Probably why we're seeing so much anthropogenic,
Yeah.
because seep sites tend to attract fish and other things.
Yeah.
Maybe it's a squid site.
Yeah.
Yeah. Yeah. So we have been noting that anthropogenic debris, maybe fishing line, maybe net, and that would make sense. These deep sea seeps tend to be a relative hotspot of biodiversity and life in the deep sea. And so that might naturally be a place where fishing activities occur. And so, as you can imagine, fishing in this area there, you might end up with some of those nets and lines on the seafloor, especially if the hard bottoms here, it can be maybe easy to snag those sorts of things. That might explain why we're seeing those around here.
Did you want me to make you keep back right in, let it pull you up, or do you want to look around the middle of the mark?
Go around with the map.
So Scott, so we're spiking again, a little elevated, but is the slight delay?
It might,
in
yeah,
the-
it's
In
probably
the SAGE
still.
system, is that mound that we went over?
It's integrating, passing back over the mound a minute or two ago is probably what we're seeing.
Cool. So we're continuing to watch our SAGE instrument to see how it's changing as we move away from that mound. And we can see the environment's changed a bit here, moving away from the mound, much more sedimented seafloor. Still quite a bit of organisms. We're seeing crabs and fish in this area, but obviously not as dense as right over that mound.
effects of the mound, or we're getting closer to another hotspot because we're still climbing.
Ah, okay. So in watching our methane sensor, we're seeing that it's climbing. So that may indicate that we're approaching another location, another seep, or another area where gas is coming out of the seafloor. We'll see as we move ahead towards waypoint 2.
Looks like a bacterial mat.
Yeah, bacterial mat coming up ahead, indicating more gas seepage. We're definitely still in a seep area. You know, a lot of folks may be wondering, well, why are scientists so interested in seeps? And I think sort of the obvious here is what we've seen so far today, which is these are hot spots of biodiversity and hot spots of life in the deep ocean. They're unique in that they're ecosystems that don't rely on sunlight. Most ecosystems on Earth rely on sunlight as the base of the food chain, but seeps and hydrothermal vents are some of the locations that do not in the deep sea. And so, of course, there's a lot of interest in understanding these ecosystems because they are very unique and different from what we see on other places on Earth. Additionally, a lot of scientists are interested in understanding seeps because they tell us something about the geology of the seafloor. They can tell us about the gas underneath the seafloor, and we can measure that gas to understand how it was created, whether it's being produced by microbes or maybe is much older and was coming from organic material that was buried millions of years ago. We also know that when this gas comes out in the ocean, particularly methane, it is oxidized by microscopic organisms in the ocean, and when they consume it, they produce carbon dioxide and they consume oxygen. And so around seeps, we might expect there to be also changes in oxygen and changes in carbon dioxide in the water, which can directly lead to changes in the pH or the acidity of the water as well. So that's another reason scientists are interested in these sites is we're just in the last few decades coming to understand that there are these numerous sites where carbon in the form of methane is being moved into the ocean, and it's important to understand how that affects the larger ecosystem. One of the scientists on board the ship, Lisa Levin, has sort of characterized this as what she calls a sphere of influence, where that methane influences the sea floor and the water around it, and that affects the chemical nature of the environment, the biological aspects of the environment, the physical aspects of the environment, and so there's a lot to learn about these sites, and it's always exciting to find a new one, as we have today. Oh, and we have bubbles again, gas bubbles escaping from the sea floor. So clearly, we find ourselves on a methane seep site. This appears to be another mound type feature here. So we've moved from one mound to the next. And how's our methane sensor looking?
Still going up.
Still
And
going up.
We're over
Okay.
70 ppm right now.
Over 70 parts per million. So even greater amount of methane discharge at this site. So very exciting.
were talking about different reasons why we couldn't study these things, I often think about just back to the carbon cycle, that we're, expanding our understanding of how carbon moves around on Earth, and that, it was generally thought that most of the carbon in the organic carbon that gets buried in sediments was trapped there. But as we're starting to explore and characterize more seeps globally, we're seeing that most of our margins are pretty leaky when it comes to the carbon that is trapped in the sediments.
Yeah, that's exactly right. And I think sort of an important side to that too is, as we think about the carbon cycle, we're learning that seeps are, as I said, this sort of unexpected pathway for carbon to move from being buried in the seafloor to right into the ocean. But it's also important to note too that that carbon largely appears to stay in the ocean. It does not, for the most part, appear to make it to the ocean surface and enter the atmosphere, at least based on the studies that have been conducted so far. It looks like microorganisms living in the ocean tend to consume it before it can get to the surface in most cases, particularly in deep sea sites like this one. There are a few examples of seeps that are in very shallow water or even right in coastal zones in the intertidal zone. In fact, there's some right here in Chile on Mocha Island that we may be visiting later in this cruise. And those are sort of special sites where that methane goes right into the atmosphere. And of course, we know that carbon in the atmosphere is a special thing that we want to understand and understand where it's coming from and how it plays, how it moves through that global cycle.
We've dropped off quite a bit on our methane, down back to the 30s.
I think
So
this is coming from moving across that mound and then taking time for the gas to come out of the fiber.
Okay.
So it feels like we've been down here a long time, but it's not actually that long
No.
instrument wise. So
Yeah.
I suspect this will flatten out from our transit back over to waypoint 2. We'll
Right.
see another spike in a couple of minutes from waypoint 2.
Mm-hmm.
The live data can be a little bit hard. We usually back process it with a time delay to truly map it to where we've been.
Yeah. And Scott's telling us that watching the methane sensor in real time is actually watching methane from a few minutes ago. So when we see things on the video that would appear to be in a high seep, maybe a higher area of seepage, you'll probably see the biggest spike a few minutes after that. So if we spend a lot of time at a seep site, we'll be elevated probably for most of the time, and then as we move away, it'll slowly fade.
And development of a sensor like the one that we have on the vehicle today, the SAGE sensor, is important because traditionally to find seeps, we've used things like sonar, and while that's very useful and today was successful in helping us find the site, we know that not all seeps always have gas coming out of them or always have hard grounds we can see on sonar, and so to have an independent instrument outside of a sonar can measure methane in the water column and tell us perhaps where those concentrations get really high. That's just another tool we have to help guide us in ocean exploration to sites like this. Ooh, was that a predation event? No, looks like the squid might be hunting.
Yep, so based on our map, we have moved off of waypoint 2, which looks, I'd say it was about similar characteristic to waypoint 1 with the same type of fauna.
That's right.
And now, what's waypoint 3 is another one of these kind of mounds. We're in a string of them, aren't we?
Yeah, waypoint 3 is another sort of mound with high reflectivity seafloor, and they are lined up in a bit of a string across the seafloor, sort of a chain of these features. They're not quite in a straight line. If they were, that might suggest to us something like faulting or fracturing of the seafloor was serving to allow gas to escape along a line, but nonetheless, it's we, especially the geologists in the ship, sort of puzzle through what might be beneath the surface, controlling where gas does come out and where it doesn't come out in these sites. And we see a bacterial mat ahead again, so we certainly continue to be in an active area.
Yeah, these bacterial mats seem kind of like the suburbs of the seep sites.
Yeah, the exurbs are sort of
The exurbs.
Yeah. Well, that might, you may be on to something there. We know we're seeing with the SAGE, the concentrations are highest right over the mounds and sort of decrease away from them. So different types of organisms find their. Oh,
That was
definitely a predation
yeah,
event there.
predation
Yeah,
event.
that was breakfast.
I know how that squid feels.
Yeah.
It's breakfast here too right now.
That's right, I know. Wonder what's for breakfast on the ship today.
Yeah.
No doubt something delicious.
Mhm.
Outstanding meals by our outstanding chefs here on the Falcor 2. Is that a brittle star? It's a brittle star over there.
What else besides bacteria? There's carbonates.
So we're continuing to make our way towards waypoint 3 and keeping our eye out for more indicators of seep environments as we had on those first 2 mounds we visited.
Has there been any, is this
Next one.
Oh, looks like squid's setting up for another meal. This is really exciting to see the Humboldt squid feeding, or trying to. It looks like we may have another bacterial mat ahead. Been seeing lots of those today.
A lot of bacterial mats don't seem to be particular. There's lots of patchy bacterial mats, but not like that really large, expansive ones that I've seen.
In fact, that is not a bacterial mat. That might be some debris.
Marine debris.
Marine debris.
Well, I'll tell you, it's, the methane sensor was saying no methane. We're back to almost baseline.
Very interesting. Yeah.
So-
Looks like the sensor is agreeing with obviously what we're seeing here in our Sebastian video, but also what we saw with the ship sonar. So it's nice to see when all of our tools line up to tell a story. Is that a sea cucumber?
It's an Iberian, remember? Crab inside.
Oh, an Idarian with crab.
It's an
Crab right
Iberian
there.
sorts. So what, has anybody zoomed in to see what the little tufty brown is on the bottom? So there's some holes, but then it looks like there might be some other stuff on there. Not sure. There's a lot of holes.
Looks like something ahead there.
There's a group of accented shrimp that are burrowers and
Here's another one of those tube clusters, it looks like. Been seeing quite a few of these this morning. Can we zoom in on that tube cluster for Lisa?
I don't know what you're calling tubes. They're not cylindrical.
That might not be, that might just be a carbonate rock.
There's some
All right, thank you.
Yeah. Okay, good to know.
like that we would. There's a lot of fauna things on there that would be useful to have to record. When we come back to this, see how drop a tab or something. Can we drop a tab so we can come back to that rock so we could eventually.
Can we drop a waypoint there?
Yeah, drop a waypoint.
Thank you.
Like that rock probably had 20 species on it, or it would want to record what they were.
What would you like me to call the marker?
Huh?
Marker name?
Was that a rock?
It was a carbonate rock.
Carbonate rock with
Fauna,
species?
yeah,
Rock
species.
or
Full of animals.
full of animals.
Calcium carbonate, CaCO3.
Yes. We could do
I'm not gonna write the whole thing.
animal bundle.
Okay, animal
too.
bundle.
There was quite a few things on it.
Yeah. There it is. So this looked like those tube clusters we saw earlier, but it is not. It looks, as we approach it, to be in a carbonate rock. And you can see there are numerous organisms attached to it as it presents a hard surface they can attach onto.
There's circular words are the little white squiggles. So you can write just turn over. It's coral, octocoral.
So we have some of our biology colleagues here sharing that we have some octocoral and serptulids on this rock that we found here.
Is it useful for me to tell you what we're seeing or? No, go ahead. Unless you want to.
How many?
Those are
Yeah, and they were huge, they were just huge intricate clusters.
So there's
Are-
hydroids
So we're seeing hydroids here,
and galatheid crab.
galatheid crabs.
Sponge.
Oh, we have a sponge, deep sea sponge on this rock.
Serpulid polypes. The little white squiggles.
Little white squigglers, they're serpulid what?
Polychaete.
Polychaetes, worms.
hidden in the crevices, and maybe Nizumia is the fish. I'm not so sure.
So perhaps the fish is a Mizumia, hiding there behind the rock. Okay.
So this is what I found out, like the rocks on the like they're like little oases.
All right.
No, they should take it one. She does.
Are you okay?
Yep.
Yeah. So I think we can continue making our way towards waypoint 3. Thank you for zooming on that one.
Are you mapping?
The M3 is broken. So we didn't do any mapping. We've been doing SAGE kind of observations and SAGE testing with the going over the mounds.
Did it break at the beginning of the
No,
night, or-
it's a cable that they couldn't get fixed. They're working on it for a subsequent dive. So we,
So
yeah.
you didn't do it?
I know, it's kind of sad. Hopefully they get it fixed for tomorrow. They're working on making a new cable.
So the SAGE received an elevated background check. So when we were on that transit, you see up and down the huge.
So we've got the Humboldt squid here.
I think you just elevated.
In between the places?
Yeah.
And
It's at least it's elevated compared to
So that's really.
The water column?
Yeah.
A bit of a signal, you might go over Israel, which is a bit of a stretch, so that's too far.
It's looking like where SAGE is indicating that just this whole area has like a slightly elevated background methane compared to the water column, which was being measured on our way down.
mm-hmm. So that's kind of a good way to think of these sites, is you have an overall sort of seep environment where you have elevated methane in the water, but then you have those sort of punctuated points of discharge where you have those much more concentrated ecosystems around carbonate rock, as we saw at waypoint 1 and waypoint 2.
Did you guys see flares last time?
No flares, but lots of high backscatter. It's a little dark, but we have the strings of these high backscatters with the mounds from the deploy tree. So
Let's,
the dive plan has more waypoints.
it's possible. Let's take a closer look at that. What appears to be coral.
Continue over to
See
some
more
of the
there.
other smaller ones, but number 1, waypoint 1 is the biggest. Yeah. So 1 and 2 both have these tubeworm mounds.
Yeah. So I believe that's an octocoral. Is that an octocoral?
It's on
Yeah, so we've got an octocoral here attached to carbonate rock, it appears. And something sort of on the edge of the rock there, I can't quite tell.
You can see there's a big shrimp.
That's good. Yeah, we can fall off towards 3, waypoint 3.
See the big shrimp?
All right, as we're approaching waypoint 3, it looks like we have another mound type feature here. Again, this looks like an outcrop of authogenic carbonate rock, and there appears to be some, it looked like off to the left there were also some bacterial mats. So we're going to be keeping an eye on our SAGE sensor to see if our methane concentrations go up again as we approach this waypoint, and we may take an opportunity here to look at some of the, and here's the Humboldt squid coming through. Very cool. And what looks like another shark? Is that a shark?
Cat shark.
Cat shark. Cat shark.
Probably it.
Cat shark. Very cool.
Shell?
shark.
Yeah.
Shell debris?
Yeah, a lot of shell debris. Oh, look at that shark.
So do we have a marker for that stuff?
This is a waypoint that we're on.
Yeah.
Or we're
We're
coming
not-
up to a waypoint.
We're not quite on the waypoint. We can put a marker down here if you want to say
It's a good
rock
place
outcrop.
for- Great place
Oh,
to
it is.
go back and sample.
Yeah.
Okay. Yeah, if we could drop a waypoint here.
There's another.
Oh, there's a large coral feature there. Couple of corals, maybe.
Well, some of the discolored sediments.
Potential sample site.
Oh, those, yes.
Yeah.
And there's a bacterial mat right there to the left. And another large octocoral with its symbionts. Lisa, what is that?
Commensals, we would call them.
Commensals. Commensals.
Is that Oxford School now?
And do we have lasers on? Can we just turn just to see get a sense of the size of that coral? Ah, there we go. So that we have our lasers on now. Those two green points are 10 centimeters apart. So that gives you a sense of, this seems like a relatively large octocoral. Quite large for this. And so that's great. We can turn off the lasers if they want to get a beauty shot. I don't want to. That's fantastic. And that coral is attached to some more exposed carbonate rock. Wow. Fantastic. Ah, what a great shot. Beautiful, beautiful octocoral there. Those SWAT lobsters? LeGrand?
I don't know.
Don't know.
Those
Ah, so those are brittle stars on the octocoral commensal species.
Definitely two species of shark, two different species of shark. The base, drakes,
Okay.
tubeworms.
Oh, and here comes one of those cat
Those are
sharks.
tubeworms. Those are tubeworms, yeah.
Ah, we've identified tubeworms.
Or maybe, but there's some tubeworms like Siboglen and the cat shark is very cool because they live there in seeps. Well, often, not always.
All right.
It's a Galatea. There's. Look at all the little solitary coral. They're not solitary, maybe so.
Yeah. Big squid going by there. Our camera, outstanding. Outstanding. How's our SAGE sensor looking?
Still an elevated background, but still reading a relatively flat background.
Relatively flat background. Okay.
But elevated, there's a little bit of methane around.
Yeah, well, we'll see as we make our way towards waypoint 3. Are we, Lisa, are we happy to continue on? I want to take the time we
It's
need
like
for the
me
biology.
being
Yeah.
in a candy store.
Yeah.
Trying to grab me out of here.
Well, all right, yeah, I think we can continue transiting to waypoint 3.
We watched the first hour of the bad boys.
I wish I was up an hour earlier. Still a good one. I love
Oh,
that the Humboldt squid
wow.
is hanging out here.
Lisa, I know you mentioned this site could be coincident with the oxygen minimum zone. Looks like the O2 is around 26.
So we're just kind of below.
Kind of below the minimum.
Right at the edge.
I got it. And
But
that,
it's good because if it was like super low,
Well,
we might not be seeing
the
these
animals
animals.
wouldn't be as successful. Yeah, absolutely.
20, I mean, by global standards, 26 is low.
Right.
It's definitely what shallow water people call hypoxia.
Right. So we definitely have a low point in oxygen here. Not as low as it can go, but
If we went shallower, it would get lower.
yeah. And we'll watch that as we ascend. We can
Yeah, so we
see
had
the oxygen
Adam
decrease.
on the SAGE sensor, the gas pressure was lower, a little bit higher, which the gas pressure is really reading the oxygen
Yeah.
in the water column as we're coming down.
So we're a little bit below that oxygen minimum zone here. We see.
And oxygen minimum zone edges often have, I could talk about this stuff.
They have Humboldt squid, I think. The Humboldt squid hanging out at the oxygen.
often are sort of high density aggregations of animals. So
Yeah.
like these shrimp is a really great example.
So we can see here what looks to be some more octocorals on a carbonate rock outcrop. A lot of maybe sponges on that outcrop as well. Very nice. So this harder bottom is likely what we picked as waypoint 3 that we saw on our sonar. And so as we continue moving this direction, we expect to hopefully see a bit more of this. Is that a crinoid?
There's no level streams in the water column. We did see hard grounds. This is the backscatter. This is strings. High backscatter.
Ooh, another outcrop here with
Depression.
maybe some different coral. Think
It's like Swiftia.
Swiftia, maybe.
It's the right color.
Yeah.
The dark red.
Is that okay? Looks like
We saw
it's like
it.
Paragorgian
Place
color.
where,
This could be a Paragorgian.
It's hard to tell.
they went to the right spot.
But there's a bush of something different.
And in the sub-
Yeah.
you could see
Maybe a
gas
black coral.
came in, little chimney. Acoustic
All
chimneys.
right, we're starting to see more
Lots of indications of seeps.
More
No
outcrops.
active bubbles. And it could be tidal. We're shallow enough to where the tide could be the same color.
Yeah, let's take some zooms here on these corals, get a little closer look.
They stick, they stay in.
I think. Lisa, is that a crinoid?
Yep.
Yeah. Looks like we have a crinoid here in the middle of the as well. That brown and tan. and a number of sponges attached to the rock as well. That is a gastropod.
You see snails?
Yeah, to the left there, isn't there a spiral
Yeah.
gastropod? There we go.
Yeah,
That white,
is it live?
I don't know. It looks like it might be dead.
Yeah, this is probably a black one.
Just gonna go get breakfast and then the bridge meeting 7:30.
You want?
I was gonna eat and then do. I have a bridge meeting at 7:30.
Yeah, there's that snail.
If you want to. We're just doing observations and.
That's fine.
Okay.
Yep. We'll just keep going. Is that some debris down there at the? Yeah, it looks like there was. We're moving, but it looked like there was a bit of debris. I think we've been seeing quite a bit of debris around this site, and as we said earlier, that might be associated with fishing. We clearly have a hotspot of biodiversity here, and so it's not surprising that there might be fishing activities here as well. And that's a good thing, or it's important when we see that to document it as well, because that affects the ecosystem and our understanding of it.
Do you want me to introduce myself?
No, absolutely. So we'll go ahead and let Lisa introduce herself, and she can provide some fantastic context to this biology we're seeing.
Hi folks, this is Lisa Levin. I'm from Scripps Institution of Oceanography at UC San Diego. Right now I'm just filling in for Jeff while he goes to a meeting. I'm a biologist.
Yeah, so as I mentioned earlier, I'm a marine geologist, which limits somewhat my ability to identify the species, actually quite a bit limits it. But I'm very glad to have Lisa joining me this morning, as she is an expert in seep environments and will be able to give us some great identifications and explanations of what we're seeing here.
Right. So it's been very exciting to wake up and see that we're at a seep actually. We're pretty shallow, looks like 413 meters, and we're just at the edge of the low oxygen zone that occurs naturally here off Chile. And there's all sorts of indicators that of both seepage and low oxygen. So the dense, very, very high numbers of small shrimp that we're seeing here, Eulogio thought it was maybe heterocarpus, is very characteristic of oxygen minimum zone edges where animals, different crustaceans will aggregate. And you see that phenomenon all over the world, in the Indian Ocean, in the North Pacific, in the South Pacific. So those shrimp that are on the bottom, I believe they may be harvested commercially.
I don't know if you've got a Spanish speaker in it. You could send up the bridge or some VHF calls. Thank you.
Yeah, I'm going to do this other group.
We just had a call for a Spanish speaker on the bridge, which suggests maybe there's some fishing vessels or other groups we need to talk to out here.
Right, and so we're transiting here from waypoint 3 to waypoint 4. We expect, based on overnight mapping, that these first 3 waypoints were the areas we picked as having high likelihood of seep sites. Unfortunately, they weren't. And so as we make our way to LA, we've got a little bit more of a training, and we expect to wait forward and hopefully see another seep environment there. And this gives us an opportunity as a colleague test with a main sensor to see how it behaves as we transit between seep sites.
So this site is full of life, even when we don't see a lot of manifestation at the surface. It's heavily burrowed, and we don't know what's making those burrows, but it would be really interesting if it was actiniid shrimp, which are a group that apparently can live at hydrothermal vents and methane seeps of deep burrowing calcium acid shrimp. But they're usually underground, so we don't see them. Just their sediment mounds.
And Lisa, what are these fish? We've been seeing these throughout the day. Is
Well,
that the-
it looks like some kind of grenadier,
Okay.
and I know a fish, one species, Nazumia lyolepis, with big eyes that's fairly short, that this could be. I've seen them off Mexico in the oxygen minimum zone, so I don't know if that's them or another species.
Very good.
Lisa, this fish looks like Coelorhinus. Looks like Coelorhinus.
Oh, the Humboldt squid just got one.
Like what?
I think you got it.
Coelorhinus.
It's breakfast time on the seafloor,
Yeah, it is.
just like it is on the
Yeah,
ships.
that's
Okay, so we have Maritza, who's a regional expert, telling me the fish is Coelorhynchus. She can speak. Maritza, do you know the name of the small shrimp?
No, it's very difficult for
Wee,
me.
look at that sea star.
An asteroid? White?
Very nice. I think that's the first sea star. I mean, we've seen brittle star, of course, and that's the first sea star I recall seeing today.
They're predators, and they often like to eat coral. So it's not unusual to see sea stars climbing up the stalk of a octocoral.
Mm-hmm.
So is this our own cloud, or somebody else made the cloud of sediment? Do we know?
I'm not sure.
I think it's ours.
It's us.
Man.
When we stopped for the
And-
sea star.
No, it's not like-
Yeah.
So there's a Humboldt squid. Is it Dosticus? I'm trying to remember the genus of them. It keeps swimming by. I wonder if it's the same squid that's curious about us, or there's multiple ones here.
When I started, I'm 380. Oh, so they're still going. Pretty much on the we all do asking groups and then like go if you had
No, because they all, like,
sorry.
The big snails look like Neptunia, but there are several. You'd say you know the snail?
I don't know, maybe Javier.
They're whelks, also predators. So it looks like it's wonderful push court territory.
Thoroughly, I see you've moved the waypoint.
Sir.
Yes, excellent push core territory here. We're a bit away from the carbonate rocks. And, this will be
This looks like a mound of some sort, doesn't it?
Humboldt squid there.
Ooh, could we see what the tubes are over to the right?
Yeah,
There's a lot of tubes here.
absolutely. Let's zoom in on those.
Or even straight down. We're just in a, right where we are, there were lots of tubes that could be polykey tubes, or they could be something else. They're also foraminifera that make tubes that look a little bit like this also. Maybe you could just mark some kind of tube field here, and whether they are Cheiroptera tubes or Vesicomyid, which is a forap that makes tubes like this. They could be something else, but definitely a coral place. Cheiropterids are polychaetes that sometimes hang out around chemosynthetic ecosystems like whale falls and seeps.
Very cool.
And I believe they could have symbionts, although none have ever been found. We haven't looked too hard.
Yeah,
There's more tubes. You guys see we're kind of in a tube zone.
we are. There's just, I was about to mention, area of real concentration there. It'll be interesting to see if that correlates with a little bit elevated methane sensor.
The sensor, if it's still logging, it is slightly elevated, but nothing spiking. Although Scott said there's about a minute or two lag, right?
Yeah,
So,
yeah.
Yeah.
All right, well, we'll keep making our way towards 1.4. A bit of a transit here, but waypoint 4 appeared to have what looked like pretty hard bottom there, so hopefully we have a really nice community to look at.
Are we going, we're moving shallower, right, as we go?
We are moving shallower. we make our way towards that waypoint. We're coming up an elevation a bit. I see we're at 403 right now, so about 10 meters. The next waypoint will be a bit shallower.
Yeah, thank you. Can I have a picture?
So, Lisa, I know we have at some sites, in other parts of the world, the foundational species are types of mussels, like Vesicomyid. And in some locations, they're completely different. They're things like tubeworms. What might we expect here in terms of the chemoautotrophic foundation species?
Well, it sounds like you saw tubeworms this morning, so
We definitely
they'll
saw
be one
clumps
them.
of tubes, yeah.
So that'll be one. I mean, I would expect some Vesicomyid clams,
Uh-huh.
white clams with symbiotic bacteria
Mhm.
that oxidize sulfide, because they're very tolerant of low oxygen. A few species are.
Ah,
And the
I see.
oxygen's still pretty low here.
Mm-hmm.
For some reason, probably related to oxygen, we never see big mussel beds in the oxygen, in or near the
Right.
oxygen minimum zone, so I
Mhm.
don't expect those.
Mm-hmm.
But I think one of the things we're starting to learn is that there are other taxa that tell us there are seeps, like aggregations of hydroids,
Ah,
or
yes.
arborescent foraminifera, which are things we've seen on those rocks. Corals usually hang out around the periphery of seeps,
Okay.
not right in the middle. But we have clearly seen corals.
Yeah.
They can be foundation species.
And we did see, I'm not sure if we saw any live clams, but we certainly saw what appeared to be white bivalve shells, which look like clams this morning as well.
This looks like another aggregation of tubes down there.
Mm-hmm.
And, could be that whatever those are, that they become foundational species. We
Yeah.
know that other animals and small and microbes can live on the tubes as well.
Ah, we have, is that a shark?
Ooh, a different one.
Different species, certainly.
Or is it a shark? I guess it is.
Not sure.
Terrible with fish.
Yeah.
Tail is very shark-like. You know, Maritza, what that is?
I don't know what
Get a
is
good
shark.
picture. Frame grab, maybe a BBC highlight.
Maybe with the Humboldt squid in the background.
Yeah.
Beautiful. Oh, he swam into the ROV.
Hungry.
Oh my goodness.
Where is he?
He's. Oh, and that squid just caught a fish.
It got it.
He got the fish. My goodness.
That's a video to go back to.
You've got it highlighted, BBC?
Yep, I see a new color and to the northeast.
Yep, that was one of the things I wanted to do. We had something like
I guess we've got somebody here anyway. Get it.
Yeah, pink or something is a little bit better for us, a little bit more back under the other screen.
Oh, you got black, okay, I thought we had the graphics, I'll put it back to agenda.
No, we don't have the premium
There's
package.
several Humboldt squid in the background
Mhm.
there.
Thanks.
Another.
Oh, nice. The eyeball. So cool.
They're telling their friends.
While we were flying around this whole time, just out of view, the whole time we've been down here, we're just out on day.
Probably our lights are attracting their prey.
Yeah, they've been hanging out kind of in the shadows, just catching fish that are stunned, it seems.
Yeah.
That's so we're feeding the squid, basically.
Anyway, yeah.
Perhaps we're.
So we're between waypoints 3 and 4 right now, is that right?
That's right. We're between waypoints 3 and 4. There's sort of waypoints 1, 2, and 3 were a bit of a semicircle of hard grounds, which all turned out to be carbonate mounds with abundant chemosynthetic communities. And there 4 is the start of another chain of those as well. So anywhere on that map you see lighter spots. Those turned out to be seep locations.
And it's hard to say that all the carbonate rocks have seep communities because they're also typical of background, some of those, not the tubeworms, but all the other taxons.
Absolutely.
So we kind of need to look at them in different ways.
Oh, absolutely. Yeah, that's just sort of in the absence of bubble streams. That's turned out to be the most reliable way to find them here.
It shouldn't affect us. Right, it's definitely the DVL. Right?
I'm very intrigued by all the tubes. I want to know what they are, so hopefully we'll get a push core later.
Oh, absolutely. Got some water column animals here too.
Yeah, Roger.
Amphiretids are another
Amphiretid.
polychaete that makes dense tube fields and seeps. So
Ah.
Is it bad? Okay, yeah, you can see it right. Never mind.
So the thing about a mud bottom like this is most people don't realize that it's teeming with life beneath the surface. There are a lot of small polychaetes and crustaceans, worms, crustaceans, mollusks that live that might be only a millimeter or 2 in size, and usually they're really dense.
Mm,
It shouldn't shut down.
that's really
We
neat.
see them when we take push cores and sieve the sediments.
Yeah. Yeah, this is. Looks like there'll be a lot of good opportunities for sampling today.
The fish density is pretty high. These small
I was gonna bring it in
Mhm.
different depths and certain.
Coelorhynchus.
Yes.
They look like baby, little tiny
I
grenadiers.
mean, in theory, I could cause INS to drop out.
Which should still allow a DVL signal.
That's my understanding, but I didn't test it.
Okay.
So I can't even test it anyway. Yeah. I mean, in the ground fault, you don't want to.
Looks like maybe an anemone. And more marine debris. And still lots of tubeworms, or tubes in the seafloor.
Okay, those aren't tubeworms.
No, is that debris?
Oh, that could be a tubeworm. Or a coral. It looks like a black coral stalk or something like that. Not sure what that is. Unless it's a buried plastic.
Yeah.
In
Yeah.
which case, never mind. It is covered with hydroids.
It is.
And an anemone, so it's a good example of how any hard substrate gets used down here.
Even marine debris, yeah. Or is
Yeah.
that, there's something on the left side of that. I don't know if those are those,
Might be,
doesn't look like, couldn't tell.
might be foraminifera.
Yeah.
Needed foraminifera there. Fluorescent ones. But the thing about tubeworms is we reserve that term for siboglynnid polychaetes.
Yes. Yeah.
And other tube-making polychaetes, we tend to call them other things.
No, that makes sense. Yeah, I don't.
But all the fuzzy stuff that we see attached to our living organisms looks like some foraminifera.
Hmm.
And our shipboard experiments with labeled methane show that they have the ability to take that up, probably either through symbionts that oxidize methane or by filtering the amount of methane oxidizing bacteria out of the water.
Right.
So nobody really thinks of them as seep creatures, but they can be.
It can be. Very interesting.
Somebody suggested that shark could be a dogfish. I'm not familiar enough with the fish to know, but we could look up dogfish. Yeah, looks right. A bird-beaked dogfish.
Bird-beaked dogfish.
Could be what we were seeing at that shark-squid encounter. That was somebody from the chat.
Should we just kind of wander along like that? Yeah. No, that's good, actually, because we don't have any option but to get fine.
Lisa, do you know, is the Humboldt squid a commercial species?
Yes.
I thought so. So it's, the abundance here and the fact that we saw a lot of fishing gear suggest could be a target species.
What did you see?
We saw some net and we saw some monofilament, thick monofilament line.
Maybe can't, is there a reason? I guess we're gonna try to hit all the waypoints, right? And then
Yeah.
before we sample.
Yeah, we just laid out these waypoints because they looked the most promising and gave Scott a chance to test out the SAGE sensor. But it's really at any point, we can deviate from the plan.
Well, I'm happy to follow the plan, but I'm just curious. So we were gonna go to the 4 waypoints and then we can go back and sample?
We
or
could go
wanna
back and
keep
sample
exploring,
where
or-
we started, or we can keep exploring. We can provide more waypoints to the east to keep exploring that direction.
Yeah, it looks like there's a string of high reflectance spots.
Yes, that's
To
right.
the
Where you
east
see
of
those lighter
4.
spots, those are what are turning out to be the
The rocks.
seep sites. Yeah.
Where was the biggest concentration of bacterial mounds?
I guess probably right around when we started. Does that sound right, Scott? Around waypoint
Between
1?
waypoint 1 and that big mound.
Yeah, the big
Yeah.
mound.
And the big mound is at 2?
Yeah. Big mound is between waypoint 1 and waypoint 2.
It's kind of, it's just off the waypoint. It's at the bottom of that high reflectance space. Yeah.
All right. And it looks like there's sort of some big mound features here, right? Like
Yeah,
a meter,
the-
meter high or half a meter.
It really is. The seafloor is a little more hummocky or mound, having mounds than I would expect in this location. I'm not quite sure what to attribute that to.
You don't think it's methane underneath, pushing up?
It could be. Well, we did see some of that on the sonar survey last night, where you see pretty clearly these sort of what we refer to as chimneys, where gas is coming up through the sediments under the seafloor, and some of them did have mounds at the top of them. So that could be what we're seeing here. It's a little hard to know, but there is sort of this sort of rolling hummocks that we're seeing on the seafloor here.
Where were the chimneys?
They were largely associated with the lighter colored points on the map, where we have
Okay.
the I think it's carbonate rock.
They were also somewhat scattered around.
Yeah.
There was a bit of a randomness, a little bit concentrated around.
That's right.
When
So
I
we
sit
see
up
them
there.
concentrated around these mounds, but they were kind of scattered throughout this area. We surveyed quite a bit of this area last night and saw them, particularly I think we saw some to the large ones to the north of here, and the west of here, and a few to the south.
Again, the sort of So could you just mark tube field for observations, please? They're not tubeworms, but they are some kind of either Malachite or protozoa.
It's worth noting that as we're moving upslope and getting a bit shallower, we're seeing our oxygen saturation drop now below 20.
So we're officially in the oxygen minimum zone.
We are. Yeah.
And that's useful to know. We're at 394 meters.
Mm-hmm. I think if I remember correctly, when we got to bottom, we were about 400.
Oh, wait a second. I'm seeing 59 micromolar.
Yeah.
But that's the cut. Yeah. So that's not the oxygen minimum zone.
Oh yeah, I was looking at O2 saturation.
You take it back. Actually, it looks like the oxygen might be going up. But it shouldn't be.
I like your talking about SOI Divestream, it's a lot of people.
What was it back at the start of the dive?
Oh, squids.
Started back yesterday. I think it was.
No. But I meant this dive. Has it been going up or down?
I don't remember.
I think the saturation's been going down.
So maybe, sort of a general definition of hypoxia is around 63 micromolar, and we're at 59. So we're in hypoxic waters, but
Mhm.
oxygen minimum zone is usually defined as being 0.5 ml per liter or 20 micromoles.
Oh,
So
okay.
we're a long ways
Sure.
from being in that,
Yeah, certainly.
if we believe our sensors.
And SAGE is reading the same for dissolved gases, so they're coming down in the total dissolved gas, which is mostly oxygen.
It's really warm here, 7.8 degrees.
Yeah. We'll see
For,
more,
for
doesn't
those
it?
of us who work in the deep sea and we're used to...
We're used to 4, 3, 2.
Yeah. It seems like warm water. I'm not sure I'd want to swim in it. But
Not for very long.
a jelly. A ring of something.
Well, it was definitely a goal with the oxygen sensor to characterize places away from the seeps or the high reflectivity. But I'm hopeful that as we approach waypoint 4, we'll start to see some higher density in species, and those may be the places to target for sampling later today.
Are those clam shells or something else?
There's very small hermit crabs. Actually, they look like small hermit crabs. They're spiral shells.
Oh, that's a different fish. Is that a hake or? We need a fish guide out here.
We're seeing these, are those sea anemones? Stock sea anemones?
I think so.
Yeah. I noticed we've seen a number of those today. Coming in for a close-up.
Should have brought my glasses.
Yeah, we're still seeing these tubes.
We haven't done any sampling. They're just going to the waypoints right now. I'm gonna run and get my glasses. Oh,
Up, got him.
Oh, got it.
just gonna run and pick up my glasses.
Okay. Are you believable? Perfect. Okay.
Give you a chance to go get them.
That's what it is. I got it. Oh, I didn't. I think it's not dark. No, because I noticed this again. It's really not going down very smooth.
All right, so we continue to make our way over towards waypoint 4. And we're seeing a lot of these Humboldt squid this morning, and I've seen some very cool predation events. Is that a ctenophore in the water? No. Ctenophore. There's some ctenophores up in the water column. Oh, very good. Well, we're continuing to see this sedimented bottom with tubes and shrimp and lots of Humboldt squid in the background. And looks like a cryonoid there we're going over just now.
Happy to go to breakfast, or if you want to stay till late.
Oh no, that's quite all right. So Lisa's back, and we're going to turn it over to her. She takes over the lead of the watch, and they get started with some more identifications and I assume some sampling very soon. So I'll turn it over now.
So hi everybody. The 8 to 12 watch is just coming on, and maybe we can introduce ourselves. So I'm Lisa. You heard from me a few minutes ago. I'm Lisa Levin from Scripps Institution of Oceanography, and I study lots of things, but among them methane seeps and oxygen minimum zones. So this is a really exciting spot because it's the confluence of both. We're in a low oxygen area, and we appear to have found methane seeps here. So that's great. Okay. My co-lead here is Pachi. Do you want to introduce yourself? The microphone. just say hello and maybe a few words in Spanish.
Sí, bueno, buenos días. Muy interesados en ver lo que aparece aquí en este sitio. Por primera vez podemos ver lo que alguna vez se pudo constatar a través de muestras tomadas con rastras, con multicores. Así que muy contento de poder ver lo que pasa aquí.
And then we have Paola as one of our loggers. You want to introduce? Yeah, of course. Hold the microphone, maybe. Paola and Erin, they can take turns.
Hi everyone, I am Paola. I am this watch documentarian along with Erin, who is going to be introducing herself very shortly. I am from Puerto Rico, but I am currently representing Dr. Turber's lab, and we love to study microbes in the sediments. So if there's methane seepage here, we all get some really interesting and unique microbes, usually endemic to the region. So I am very excited to see what we find today.
And Erin.
Hi, this is Erin. Like Paula said, I am a data logger this morning. I am also super excited about microbes. I come from the Marlowe Lab at Boston University, where we study geomicrobiology, and I'm hoping for some really beautiful chemosynthetic ecosystems today.
So that's our watch, and right now we're traversing between some waypoints that the geologists developed last night based on reflections, acoustics. So we're between waypoint 3 and 4. We're hoping that there will be some hard ground, maybe some carbonate at waypoint 4. What we're seeing now is a seafloor that maybe to many people looks like it doesn't have much, but in fact the seafloor is filled with life. Lots and lots of tubes. We don't know what's making those yet, the very small ones at the seafloor, probably polychaetes. There could be foraminifera called bathysiphon that make tubes that look just like these as well. There's a load of shrimp, and I don't know if it's heterocarpus or another shrimp. The small ones occur in really, really high densities here, and that's actually a characteristic of oxygen minimum zone edge habitats, to have high densities of crustaceans, sometimes high densities of brittle stars. And then I'm told the fish are Coelurhynchus. I think there's quite a lot of them as well. They're the little grenadiers or macrourids that you see, little small silver ones. So what we might be looking for if we're coming up on actively seeping areas is to see an increase in clam shells, dead white shells, for example. So kind of, I see some white things on the bottom. It's a little hard to tell if they're shells at all. Maybe tubes. We clearly have several species of shrimp. I'm sure the big ones are harvested commercially. I'm not sure about the small ones. This is an exciting place because at these depths there is actually a lot of human activity in the form of fishing, probably shrimp trapping and bottom fishing. So, and certainly the giant squid are harvested. So understanding the methane seeps will help us with management of fisheries and conservation actions. Looks like prime squid feeding grounds.
Yeah. They're kicking up a lot of sediment too.
But not, I mean, the sediment being kicked up is probably part of their activity, but they're not trying to hide or, there's a cat shark, over in the corner, I think. There are some fish that, when they see a sub or ROV, they'll just dive bomb the bottom and make a cloud, and they know that we can't see them. It's a pretty busy bottom, though. Every time you see a burrow, a hole, there's somebody under there. Could be a shrimp. Every time you see a structure above the bottom or a little aggregated sediment, it means somebody inside the sediment's been at work.
It doesn't get dark unless it's closer.
It's interesting, the Humboldt's squid that seem to hang vertically looking for their prey, don't they? I've never really watched how they fish, but I don't know if they're using our lights.
Yeah, they seem to be striking just on the edge of our light every time. Not close enough.
Just out beyond us, yeah. There's like an umbellula, little stalked cnidarian that's brownish. They're common also along margins. Not necessarily a seep associated. Everybody looks so calm and peaceful down there, hanging out. Except the squid. They look busy. So there's another asteroid. And I can't tell if it's next to an anemone. Some sort of cnidarian. Ooh, could we zoom in a little bit on that?
Guys, we're stopping here or we're continuing on?
Are we at waypoint 4?
And then we're
Not-
going to turn
not
around
quite.
and go back the way we came. Is that accurate?
Okay,
Well,
I don't have any
We
waypoints up
we
here.
may not.
This is-
We may go to the next. Can I have one of those?
Yeah, stand by. We'll let you know what we know.
So there should be some hard ground right around here. Let's take, before we pass waypoint 4, we should look around. Looks like a big feature.
There's something down below you want to take a peek at.
There. Could we just zoom in on that rock and take a quick look at what's there? All right, the rock has, it looks like an octocoral, shrimp, lots and lots of hydroids, and foraminifera, which, as I mentioned earlier, could be using methane. Okay, could we just get a frame grab? loggers, please. Yeah. So this fuzzy rock doesn't look like it has too much, but probably there are all sorts of annelids and other organisms along with hydroids that live in there. The carbonate rocks are made by microbes. It's a little hard to tell if that's carbonate underneath all the organisms, but they're made by anaerobic methane oxidizing microbial consortia of bacteria and archaea. And the carbonate is a byproduct of their activity. Okay, we're not really at waypoint 4 yet, right? We're still
We've got
some meters.
80 meters away.
How much?
About 80 meters away.
80 meters. Okay, let's keep going there.
Yeah, it's like, yeah. I wasn't gonna make it done, just pretty shallow
I'm thinking that, you know, depending on what's here, we might go back to 1, which is, you know, to due west, right?
Okay.
But let's check this out, and if there's interesting things, we'll start the sampling.
All right, sounds good to me.
Lisa, if we go from 4 to 1, we'll go pretty much dead over that map with all the tube as well. That's just south of Quisco.
Okay. Oh, see? We are coming up to a bunch of dead clamshells, which is always a good sign that we're approaching a seep. Although a little white shell hash in the bottom is probably dead Vesicomyids. So can we slow down and take a look at the bottom? There's a tube that definitely looks like a lamellobrachia tube, a siboglinid polychaete that has symbionts. Tells us we're in seep vicinity. You can see lots of things living on the tube as well. Doesn't look like anything's alive. We don't see the plume or the tentacular plume or any other part of the worm, so it's probably a dead tube. Okay, we can keep going. Thank you. There's a rock. Again, serpulids, hydroids, maybe some forams. Oh, dead fish parts. That's interesting. It looks like the squid have been feeding here. And the shrimp are on top of them. Oh. Wow. Putting on a show for us, this giant squid. Nice anemone.
seen this much squid activity before.
No, but I've never been here before. We were just being asked whether we've seen this much squid activity. I'm going to guess it's normal, but for this region. There's another tubeworm that we just passed over, the potential lamellibrachia. Any evidence of anything hard ground coming up at all?
Nothing looks like on the sonar to specifically say. Unless it just transitions just very smoothly.
There's another one of those little transparent ring jellies. It looks like a white disc floating by. Pretty interesting. Beautiful. Oh, let's see. Another cat shark. Cat sharks are interesting. I've seen them at most shallow seeps, at these depth ranges, and they lay their egg cases sometimes on corals or on carbonate rocks. We don't know exactly why. If they benefit, they also might use hydrothermal vents as well. Somebody's got to root for the fish. They look well fed, don't they? We're talking about the giant squid here that are putting on a nice show for us. But I'm guessing these shrimp, of which there are many, many on the bottom, are also pretty well fed. Okay, so we're at waypoint 4, is that correct?
Yeah, we're talking 20 meters away. Pretty close.
Okay, so they're supposed to be in the vicinity and maybe off a little bit to the west, hard grounds, based on the reflectance map. So we need to kind of poke around before we leave here.
So there may be something.
Should we check that out?
Yeah.
Thing about roaming around on the seafloor where you make the light is that it's very easy to pass by something just a few meters away and not see it. There's something hard to the left, just a rock maybe, covered with serpulids. Oh, it's definitely carbonate rock. There's another. And another. Some mounds with white sediment from below. These are definitely collectible rocks in the size range that would fit into the bio box. But let's just keep looking to the left a little bit to see if anything else shows up here. I mean, it could be that the sediment here is a thin layer on top of rocks. It's hard to tell, but there's some corals suggesting that they're attached to something hard down there.
Just like spin around the other way just to help our umbilical.
Okay. I feel like I'm on one of those.
So are we? What direction are we headed now? So we're faced west. Are we poking around? Or yeah, you want to explore a little bit, correct?
Yeah, I think we may do some sampling here before we go back to one. There's definitely hard substrate. Could we just look down? Yeah.
You want to kick the other focus? Yeah. Cool.
These are all carbonate rocks. This. But we're not seeing bacterial mats, which would be our strong evidence of seepage. No, we haven't seen any living clams either. So I think we're at the reflecting patch.
Okay.
But did you say you saw something else in the sonar that we might?
This was like kind of a dip. That empty spot on the sonar. I don't know if it's going to be any rocks. It may just be.
It's just 20 meters away from here.
Yeah, it's pretty close. Go on over there and look. You want to check it out?
Yeah, why don't we go check it out and then we might come back here and do a little sampling. I mean, there are definitely more shells here. Just not seeing living clams. So we're heading just 20 meters away to check out a feature on the sonar that looks like a hole. bottom does seem to be littered with little white bits of shell and carbonate. Then the densities of creatures. So here's more rock, it looks like. So that's good.
Yeah, big layer.
Asteroids, all the fuzzy creatures. Oh, tubeworms. Could we just home in on the tubes here, cluster here? Is the methane doing anything?
Not yet, but
Okay.
at least it takes a few minutes.
Okay, so can we zoom in on, let's see, that red, where the red plumes are sticking out, because those are probably live tubeworms, or live worms of some sort.
Oh, yeah, there's one back here. Trying to hide from us.
Beautiful. So this is probably the big mound that was at waypoint 4. Thanks, good that we went over here. Beautiful. All right, I think we can officially say we've arrived at a seep. You guys can mark the BBC highlights. I know we were at this kind of environment earlier before I woke up. So it looks like a carbonate mound with what's probably Lamellobrachia tubeworms. These are polychaete worms in the family Siboglynidae that have no mouth, gut, or anus, but they do have a lot of symbiotic bacteria, usually sulfide oxidizing bacteria. And methane seeps are interesting because the first microbes that get the methane live in consortia with bacteria that produce hydrogen sulfide. And it's that hydrogen sulfide that feeds the tubeworm symbionts.
It's just gonna react more quickly. Yeah, that's why we keep that up.
So we're just waiting for our dust cloud to dissipate. All those tubeworms are probably coughing and sneezing and trying to get that mud out of their plumes. So that was a good aggregation, several clumps of tubeworms, and we'll try to do some sampling here. There's not a whole lot of current, is there, blowing it away?
Unfortunately, no.
We can try it. Yeah. Okay.
Well, it's our sensors, sensors. So we end up more likely to get this. So we end up typically if we have this ability like this console, and also is an angle like if we're working with those. So we'll need to turn off.
Paula, did we make a decision that the lead's also going to fill this out? Okay, so the set was here.
It was an extra.
Okay.
Just that. So like, so that way, when it was glaring, we could just walk. Yeah. That's fine, we get That's the only one I'm gonna go the rest of Is that the one? Are they low there, or are they just level far? No, so they're all up in the water.
So when we do get some visibility back, we'll probably want to do a combination of sampling some of the tubeworms, suctioning the hard ground mound,
Okay.
and looking for some solo rocks that are either breakable or on the around the periphery that could be picked up and put into the bio boxes.
Okay.
I don't even know about this.
Gotcha. Can I Alex zoom in on the map so we can see where Schmidt showed us? I'd like to set us down so we can just wait for the bits to go. What's up? To get wait for the bits. Set it down so you can. Yeah. I was just trying to pick out our landing spot.
You're gonna land right on the worst spot.
Thanks for the context, buddy.
It's just melt that you know it's.
Is there any place to read lat long on these screens?
Yeah, so in the top left corner of our map.
There it is. Okay, thank you. So some of these smaller rocks also could be collectible.
Okay. You have see a spot you want us to set down? We can.
Let's go back to where all the tubeworms were. I guess it's the other side of the mound. I know the coral people will also want a little snip of coral, the coral quivers.
testing of sediment over
Let's try to get some good video up before we start sampling, because we'll be kicking up more of it.
Yeah. Do you have trims on? No. So you're actually heavy. Yeah, probably. Yeah. Just push the button. There you go. Now you're. Might make it easier to sink down and gesture on it.
Great.
Anything specific you want to look at? Anything you want to
Yeah, I think we'll want to zoom in, if you can get stable, and we'll take a look at what's living on the tubes and how they're configured, get some good pictures of them. Frame grabber people, grab frames.
Yeah, well, once we do it, it's probably gonna.
So there's definitely different sizes of these tubeworms. Let's see what Greg has to say. They're the Melobrachia. Oh, look at the skate. Well, it's either maybe it's a ray, but skates and rays also hang out at methane seeps and lay their egg cases there, so that's pretty interesting.
Do you know the species name of the tubeworms?
The Melobrachia. Oh. So do you, what? Oh,
No species.
do you want them in a bio box?
One clump would be great.
Yeah.
I'd like 10.
Okay. So we'd like to sample these. But I feel still like we should do some more close-up video. Really.
Good frame on the ground. Beautiful frame on the ground, but one that's not.
Yeah. What we'd like to do is try to get max zoom in on some of the ones that are out and photograph the crown, the red part is magnified as possible.
To do that, we're probably gonna just have to land, wait for the visibility to clear up, and wait for it to pop back out to get a stable enough platform. To get a stable enough platform to do that, we're probably gonna have to land on the seabed and wait for the visibility to clear. And then we can fishing.
Okay, well,
We can't do full zoom over.
you can't do, yeah.
We can't just do fishing.
Right. Yeah, I'm just thinking before we start sampling and pick everything up, it'd be great to get some really good photographs of these, so.
Okay, we can try to just punch in really close and just keep it steady. Can you zoom that out?
See where we are?
I know, but I still see it really close. Shot now.
So we can go do the pictures, but we'll pick up the bottom because they have to land. Do we want to take the time to do that or just take samples? What are your preferences?
Good pictures and samples. But it's possibly any speed.
What?
But they can't, unless they land, it'll not be a stable picture, so, and we know that the minute
Do you
you,
want to pick up rocks here? Okay.
I do.
Yeah, so we'll land.
Right.
If you get in a position where you can
Yeah.
sample rocks and these and do like the
Yeah, I mean, do you think if we land here, we'll be able to reach rocks and other things as well? We'll want to section this and.
Yeah, let's try to find a spot where we can just set down once, because I will pick up rocks with. I can do it.
The little fish inside the tubes out of there, I don't know what that is.
So it looks like there, is that a rock you could sample?
Yeah,
And the worms just around it?
yeah.
Let's see if we can make that achievable spot.
Yeah, it's probably good if we don't destroy the whole place while we're sampling. So we'd like to also grab a cluster of worms that Greg requested 10.
Those are fine. It's just invisibility. That's the lowest, we're gonna mess up. So we can't use it. Well, we can't use it. Yeah, let's. We're gonna probably need it.
Okay, frame grabbers. Loggers. Beautiful. Let's just hold that for a sec. It's very nice. So what we're seeing, what everybody is seeing is the tentacular plume, and the red is from hemoglobin, which the animals produce to capture oxygen. These worms also are probably using hydrogen sulfide. I don't know, I think it does also go through the tentacles to their symbiotic bacteria. Okay, let's just zoom all the way in and see what we see here. Can you pan just lower slightly? Just a picture. Yeah, can you guys try to put this one in the middle of the frame? Just pan over just a little bit. And are we all the way zoomed in now?
We are.
Okay, thank you. See, we can see the tubes completely covered with what might be arborescent foraminifera and other protozoans and some hydroids. But I'm not seeing characteristic limpets, snails, other things that sometimes live on the tubes. Okay, good with the pictures. Okay, let's go ahead and zoom out. We'd like to collect, maybe if we open one of the bio boxes, we could put a rock on one side and a batch of tubeworms on the other. Is there any methane signal here, Scott?
Nothing's come up. It's actually gone down slightly.
So we got some. Do you have a particular rock you prefer?
I would like a rock that is small enough to fit in 1/2 a bio box, but that has a lot of fuzz and other things on it.
This one just be on the right behind that one. I was gonna say that the close one.
It could be this one, maybe, or that could be broken. Is this one rock, do you think? Sometimes these crumble and fall apart the minute you touch them, so. Looks small, but maybe good. It looks like a good rock. Which bio box is open? I mean, what are you aiming for? And can we get a picture of it just in the manipulator? That would be great. Please grab logger. So what you're seeing, those little trees are actually arborescent foraminifera, probably. Little tree-like structures. Although some of them could have hydroids on them. Okay, we're good. We'll put that on. Right? Are we gonna put it in box 4?
Let's put it in box 4. We do look at the ones with the
Rock. habitat? I can't see it. We don't know yet. The idea is whichever box it goes in. Yeah. Okay, but we need to put it in because all the animals will swim off otherwise. So are you going for A or B? Okay.
We started with the bulletin.
Yes.
With all?
What?
With all? Or just once?
Everything.
Because Javier, well, let me show you later because Javier wants a snail.
Yeah, okay, we'll get everything. Yeah. Okay, so 4A, great. And maybe we could put a cluster of tubeworms in 4B.
We have the lasers on the bottom.
Okay. Oh, okay. When we go over to collect them, could you turn on the lasers, please, so we could have a scale, a photo with scale? So that rock we just collected will be analyzed quantitatively. We'll figure out the surface area by wrapping it in tinfoil. We will pull off all the animals. We'll let some crawl out overnight, and then we'll be sharing the rock with microbiologists and geochemists who will analyze the rock itself. And now we're going to collect some, what we think are lamellobrachia. Greg said it could be a new species. So we have the lasers. Let's just zoom in and you can see how they scale. So those lasers, are they 10 centimeters apart? Yes. Yeah. So we can tell the worms themselves are probably 20 centimeters long or more. Okay. Okay. Loggers, grab a frame or two with the scale on it, please. Okay, that's great.
Would you like to collect them one by one or as a clump?
A clump. As gently as possible, I guess. So just to make sure we're all on the record, the last sample was a carbonate rock in BioBox 4A. Habitat would be carbonate mound or carbonate.
Any particular location or just anywhere?
Is that a piece of fishing line? Okay, so we have some debris to record. Yeah. It's not surprising that fishing line would get caught up on carbonate mound out here. It's interesting because the discovery of the seeps in Chile really came from the fishermen pulling up tubeworms and carbonate rock, and any of the bottom fishing activities are likely to get caught up in this carbonate. Okay. Okay. So if you have some in the manipulator, you can go ahead and put them in the bio box and then just get more. You don't have to set them down. You can keep them once we pull them out. What we want to try to do is not contaminate the other side of the bio box. We don't want things falling in there with the rock because the rock samples are big quantitative on it there. What? Well, then maybe we should put them in another bio box. Is it possible to put them in a different bio box? We're a little worried about contamination. I mean, is it, if it's a problem to access the porch?
Yes, the other
out.
bio box is the porch out
And then we run into the mound?
Well, yeah, we'll be doing a little bit of our snow plowing out there, but if you can get like a grab of all of them, if we can do one dump, that would be the most ideal.
Okay.
With the scoop, with the bag?
No, they won't go in the bag. Just give them some time to try.
There is also like a big spoon.
I think this is going to be the best. Just be patient. Sure, if it doesn't risk the sample. Okay, loggers, quickly grab this, please. Okay, they got it. I know.
We're going for the back bio box now, or you want to put it in?
Oh, no.
No, don't let the squid get him. Okay. You know, that's a fairly clean sample. It can go in the front bio box if that's easiest for you guys. Oh no. So it'll be in 4B. Tubeworm. See if they can turn it. Do you feel like there's another loose batch there? Or not? Because we can just give another grab. And maybe it'll come off when you shove it in.
Does it need to be from the same clump, or can it be the ones just the same ones?
Any ones that you can get. Yeah. Diligence. I think we'll want a Niskin here also, right? No, they just withdrew. Ask Greg. We'll know. She's worried the tubes are empty. Our trusty cat shark. So the sampling of these tubes is to look and compare the lamellobrachia, different methane seeps up and down the East Pacific, compare them to the Gulf of Mexico. Greg Rouse will be doing the systematics, and he thinks this could be a new species. Lamellobrachia is an interesting siboglinid polychaete because it's one of the genera that are found at both vents and seeps, hydrothermal vents. Whale falls also? One has been found at a whale fall as well. So they're kind of a ubiquitous organism for chemosynthetic environments. So, did we decide if this was a dog shark? A different one than the cat shark. Okay. Are we good for the tubes? All right. So we're going to collect a few other things from here.
Okay.
I'd like to get another rock.
Okay.
If you see one that you can get without moving.
This one right here might be possible.
That looks like a nice rock. You think it'll fit in half a bio box?
The challenge is actually usually us getting it in the jaws. So if it fits in the jaws, it usually fits in the box.
Okay, great. We will also be collecting many of the other animals, so all the people getting antsy here about collections, don't worry. We're just going to opportunistically get what we can without moving the vehicle so that we don't have to kick up a lot of more sediment. So it's really nice to have a picture of it on the bottom before we disturb it. So loggers, you've got that, right? This rock has snails and a few other things.
You want this in the same box as the other rock?
No, no rocks will ever go together because they're all isolated samples that we're trying to quantify, keep separate. So we're going to need to open one of the other bio boxes, please. Okay, then we could just take a quick picture. Loggers, please capture that. Again, lots of fuzzy stuff lives on this rocks. Combination of hydroids and foraminifera. The snail's still there. Okay, we're good.
Preference for box in here? Is it whatever's handy for each of us to get to?
Whatever's handy.
Whatever's Alright, first one out. Where do you want to dunk this rock, Alex?
Let's try for the more challenging one because it's also that box one. I don't feel like we're gonna drop it. Let's put it to
Silver one? That's another one.
yeah, we're gonna try for 1A because that'll be that one. I would like to pursue, but
Gotcha.
if that doesn't work, like for a second,
Honestly, just could take the easiest, whatever else you can reach.
you never know when there's something really cool.
Oh, such a beautiful shark. Great. Okay, so that was BioBox 1A for the record. Carbonate rock, habitat carbonate rock. Very nice.
Let's see where Mr. Burgers comes in. It's the most annoying. Especially yeah, exactly. Okay. Yeah. It's like, that was the wrong stuff this way.
Okay, so we would like to collect some of the animals from here.
Okay.
And also do a suction sample from the mound. But we had a request for the white snail, the big white snail. I also see is that a hermit crab straight in front of us? A little trouble telling, but yeah. You want the hermit crab? Photograph it, please. Loggers, got it?
Oh, exception.
Si fuera así de short, screenshot for each species, so we can identify later. For example, for shark, the photo.
They're getting, you tell them they're doing I can't grab photos, so.
Okay.
I think they're getting, every time we stop, you're taking a picture, right?
Yeah, okay.
Yeah. And
So we can
ASNAP is as well. So I'm sure we have a picture of this one. So we have those coral quivers for the animals like this. And we can maybe. It's great. Great view. So this hermit crab looks like it's also home to some serpulid polychaetes. Those are the little windy white tubes attached to the shell. And it's living in a shell of a whelk, which is no longer alive. It's checking us out. Is there a live white snail that?
I think it's
Yeah, we think that's alive. So we'd like to collect that one as well. Okay, photograph it, please. Are we, I guess we're as zoomed in as we can be, maybe? There's another one. That one's definitely alive, because it's moving. Do you think these are easier to grab with the manipulator or suction?
These will probably, if we can, using the manipulator would be good. We have the soft red fingers. If I grab it with the tips, it should be okay.
Okay. So the snail is a higher priority even than the crab, so
Are these, how delicate are the shells in these?
they should be robust.
Okay. Should be okay.
However, one of the things we know, methane seeps have acidic waters, and so some of the animals that make shells have thinner shells than normal because of the acidity, low pH. So we'll see. But normally those snails have pretty thick, robust shells. You should be able to grab them. So for all the push core people, there is a lot of sediment here. We will have plenty of opportunity to get push cores. Some of the other sites have had bacterial mats, so we may want to wait and go back to those. But I think we're just going to focus on the fauna for a little while that are at this mound.
Sure. Yeah. I'm trying to make sure they're full. Oh. That's weird. That is the lock. That's the lock. Is it? Got it. All right.
Somebody remind me also that we will take a Niskin here before we leave, in case I forget. Maybe two. Mm.
Yeah, we're gonna have to use we'll have to use a suction sample for this. Somewhere along the way, our livers are no longer on the soil.
They're not on the soil, all of them fell off.
Looks like that was the case.
Oh no,
So,
we've lost all the coral quivers, it seems.
we can see the locking bolt, the nut that was supposed to keep them on, so it is confusing. I guess we can put that up. Those nails like to get stuck in the whoops. I'll do this one.
I mean, you could pick it up and put it in the box with the tubeworms also, if that's gonna be easier, if you can, you know. Greg doesn't care if there's a snail in there.
Cool. Give that a shot.
But that does change things if we don't have a coral quivers on here. We have to rethink.
Give it a chance.
You can also take the worm it's on if you want.
Would you like the smaller one?
Yeah, the smaller snail, I mean, yeah, and you could just grab, I mean, it'll fall off if you're not holding the snail on, but it's okay to grab the whole thing. What you don't want it to do is have it fall over in front of the manips. We'll see. It should be okay. Looks like you got a nice whole tubeworm as well. Okay, photograph loggers, grab it, please. Yep. So while we are targeting the snail on this particular manipulator mission, we have a tubeworm with it, and then a whole bunch of what looks like arborescent foraminifera attached to the tubeworm. And I'm guessing there's other small polychaetes or other animals maybe on the tube. So Biobox 4B, I would call this a whelk. Comments could be a large Neptunia-like snail. And a tubeworm, Lamellobrachia. Great, thank you. So if we have no coral quiver, maybe we could pick up that hermit crab and put it in the same box. This box will become a catch-all.
Everything box. Pick up. Gently go over toward that area.
So we think the coral quivers fell off as opposed to not ever being on there.
No, they were on there. They were on there.
Not this. Where is it? I don't know how to find it. Okay, we'll just take a look. Yeah. If we don't see the crab again, that's okay. Actually, before we do anything that stirs up any more sediment, could we trip, I think, 2 niskins?
Yes.
Please? I mean, the Niskin people want over seep. This is a seep, so. And I want some water. We'll use. So we're good. For loggers, we're gonna take Niskins 1 and 2. This is waypoint 4, if you wanna name it. We could also think of another name.
Can I explain in Spanish very briefly?
Sure. Hachi should.
No?
Hachi should. That's why she's here. You should, Hachi, just say what we've been doing. Say we're at seep that we've been taking tubeworms and rocks.
Bueno, por aquí, clase de Muñoz, de la Universidad Católica del Norte. Solo para explicarles un poco lo que estamos haciendo en este sitio. Encontramos una zona masiva de roca carbonática con algunos tubos de poliqueto, lamelibraquia. Entiendo que es primera vez que se pueden observar estos organismos vivos. Estamos tomando muestras biológicas y también muestras de agua de fondo. Esta zona es denominada el Quisco Seep Site, o una zona de coladeros de gas metano, llamada el Quisco, que está a 300 metros de profundidad. Estamos exactamente a 381 metros de profundidad. El sedimento se ve no tan reducido. Algunas zonas más oscuras que otras nos indican que hay condiciones reductoras.
Que hay un grupo, es decir, que hay un grupo de
Bueno, seguimos tomando muestras en este punto. Depende de cómo siga la exploración, podríamos volver a este punto. Hay un grupo importante de investigadores extranjeros y nacionales explorando todo lo relacionado con la geoquímica, con la geología, con la parte biológica de esta zona, siendo este uno de los puntos más someros en el mundo de emanaciones de metano. Estamos, recordar que estamos a bordo del Falcor 2. Se observan también algunos restos de sí, se observan algunos restos de cuerdas de pesca.
Yes,
o de actos
so
de
all the big
pesca.
animal collections go in the coarse jars, and you can tell us which one it ends up in. So we're gonna suction, you can say it in Spanish, we're gonna suction the crab, the galatheid maybe, and then try to collect the brachia and crabs as well.
Bueno, se va a intentar tomar algunas otras muestras biológicas. Está un poco difícil tomar las muestras de los poliquetos. Se ha intentado tomar las muestras con el brazo, también utilizando para el sistema de succión.
So it's not gonna release?
Se observan una gran cantidad de rocas carbonáticas. Estas son rocas que se generan en el mismo lugar. Son rocas denominadas autigénicas.
Took those at 12.
Y se produce del mismo por ser una zona reductora y también de las mismas condiciones geoquímicas que permiten la precipitación de estas rocas carbonáticas.
So right now we're just trying to release the mouth of the suction from a spongy. Oh, that was the sample?
Well, it's down there. You can kind of see
The crab?
24/7.
Is it this crab right there?
Yeah, good like that. Yeah, it was just out of line of sight on the main camera. That would be a good look at.
Yeah.
This is the same species right here, like.
Yeah, we'll take one or two Galathea crabs. Even we're not sure it's the same. That might be a different species than the bright orange one. Galathea crabs are typical deep sea animals. They're all over the deep sea, not just at methane seeps, but they're one of the groups that seem. Oh, we got them. Okay, what section is it going into? Okay, that's section 8, guys. Pachi 8, number 8. Yeah.
To get another one in the same jar?
Yeah.
Hold on a second.
If you can get another one, that'd be great. So it's. So Galathea crabs are sometimes more abundant around seeps, but they're also background animals that will come in and feed at seeps. And then they evolve to be other kinds of crabs. But there are definitely some seep and vent specialist Galathea crabs, my understanding. We can, if you see other crabs that are sectionable, we can.
The big one.
It might clog the tube. What do you think? Do you guys think the bigger brachyuran crab would fit through there? I don't think it's gonna fit. Spider crab is, yep. One of my favorite.
Can we put that in with the worms or in a separate bio box? It's totally unprepared.
Yeah, maybe we'll just start another bio box of animals because we don't have coral quivers, unfortunately. Maybe in 1B. We don't want the crab eating the tubeworms before they make it. So we need to be a little careful there. But there is a Galathea. Out you go. Go, buddy. Do you have a reverse suction on this? Good choice. Yeah. Okay, so that's a brachyuran crab. Hibes aranya. You guys can write down. Well, the name is Hibes aranya, so it's spider crab is generic. But is Hibes a crab name? It just means crab in Spanish, but is it a genus?
Can you repeat this thing, please?
Ask Maritza. She's the one who showed me.
Maritza, can you show us?
Crab is cangrejo.
Cangrejo, not Hibes.
Hibes as well. Hibes and cangrejo.
Hibes is one of my favorite Chilean bands. That's Hibes. The band, the music.
Hibes, yes. Yeah. The Chilean band, yes.
Yeah.
Yeah, so
Past tense, yeah, we can go back and just do one. We want me to go back in time.
Yeah, we can. So?
Yeah.
So they must be cool photos. Is it possible to track that footage to see the time?
Will they show up in HD?
So we'd like to, into one of the finer meshes, I'd like to do a section across the mound top, just to get random small organisms. Whatever, I think what you can reach from here would be fine. Over the surfaces of the tubes and the rock.
Yes, that's nice. So we want to touch a sample of
So like number, and 3 or 4, say.
So we're going to section sample of the sediment, correct?
No, the surface of the rock.
Sorry, the surface of the rock.
Just so we want to get all the small creatures that are not so attached so well, that it could be out over the tubeworms and over the carbonate. And if you see shrimp, you can get a shrimp in there. An all-purpose collection from this mound. It's a pretty anemone. Cat shark. If anybody sees a cat shark egg case, let me know.
The surface right there, huh?
Etmopteris. Etmopteris is the cat shark.
Shark. Okay. You're right.
You're jar 3. Let me just give that a wiggle to make sure.
Toyo negro.
Jar 3, correct.
Toyo negro.
Where?
This whole section.
No sé si el profe está mirando usted. El profe me dijo para él.
So if you just run it over the surfaces, we'll see. Not sure anything's going to come off. We'll see. This is basically a carbonate rock suction sample of rock surface. A shrimp would be great. It went down. It's resisting. Gotta surprise them. Maybe another crab would be okay. think it'll come up in this section? There's a request for the coral also. I don't know if you can get it into this section.
Sorry.
I'm gonna see if you can nudge that coral. The Swiftia is a little red coral right there. If it'll nudge off, it'll take that too. Mm-hmm. It might be on a rock, but oh, looks like you got it. That's great. That's great. Good to have another shrimp. There's lots of them. So touch you at that section 3. Yeah. So the rock surfaces will be at 12. We're happy to have all the little polychaetes and the mud covering the surfaces, so you can just run it over the surfaces. We'll take what comes up. Not too much mud, but just over the rock. And you can also tell me when you think the container's full or not. When we should stop. Okay, so I think we got a coral in this section. Are there any other requests in the room for specific animals on this mound? Anybody? Okay, Aaron.
No here.
Do you want cores near this, or you want to wait for bacterial map?
Bacterial mass.
Okay.
Lisa, it will still be possible to take some of the carbonate rock after you've made some. And yeah, I would say bacterial.
whatever that transparent thing is.
That's a fish head.
Oh, never mind. If it's a dead fish head, we don't want it.
That's what it looks like.
Those could be bryozoa. I don't know what that is, but that's interesting. Oh, look, there's another little crab over there on the right. Very small. See this guy? He's getting refuge. So one of the things carbonate rocks have are lots of little crevices for animals, and they hide in there from predators. That. Can we get that snail? It's alive. Yeah, it is alive, maybe. Looks like you got it.
Yeah, we may be slowing down our suction a little bit at this point. How's it feel? It's a second. This is also natural.
We're pretty sure we got one of those red corals in there, right? Went in.
Yeah.
Yeah, I think those are Swiftia, which we sometimes find around methane seeps, and their isotope signatures suggest that they can benefit from carbon fixed chemosynthetically. They might even have some symbionts. So this is all section 3. Just a grab bag of animals and small stuff from the top of this mound. You can see the carbonates attract a lot of different kinds of organisms, so they create biodiversity hotspots out here. Okay, I think we're probably good unless you see anything else.
Last chance for the fish head.
No fish heads, please. Although it would give us some fish DNA without killing a fish. Do we want a fish head, anybody? What do you think? Do we know what the fish is? Fish head. Do you want a dead fish? We're asking the chief scientist who's in the back of the room, Eulohio. That one didn't look too happy. Greg said he's not touching the fish head. We won't get it. Okay, so that ends section number 3. So I'd like to look at the top of the mound where the clamshells are to see if we can find any living evidence of living clams. Or maybe it's not the top, maybe it's the side right beyond us. So what we'd be looking for now would be siphons, openings, anything that suggests that their clams could be alive. Looks like mostly dead clam shells. The big white one? Okay, yeah. Buggers, if we can just get a few frame grabs of the terrain. Maybe we can pan up just a tiny bit, yeah, and then go back over to the right. There's a variety of what are probably Swiftia corals and maybe some hydroids here on the rock. There's also a big white coral, if you pan back out, that's in front of us. I would ask for that we get a really good picture of it. Should be maybe down on this side. That one.
We'll take a picture and also a piece of fauna.
So she wants a piece of this?
Yes,
Okay.
small.
We have no coral quivers. They fell off.
There is no coral.
No. So does Anna okay to have it in a bio box with other animals? Can you ask her?
I'm not sure.
But while we're, ask her and we'll just photograph this right now. Yeah. Elohia, can you find Anna maybe? See? Or bring her in, please. That's beautiful. Octocoral with a single very large ophiuroid, brittle star on it. Can we zoom in even more to see the on the tentacles of the coral? I know that the coral people identify them by the number of tentacles on each polyp.
Okay.
So like there's one where the polyps are all out. I don't know if we can get any closer to see it, or if they can count from this.
Yeah, that's max zoom, but we can try.
It's okay.
Focus.
Logger people, you've got some photos. So the coral quivers fell somewhere. They don't exist. Okay, so we would like to take just a small piece of the white coral and put it in the bio box probably with the crab. Yeah. box 1B.
Okay.
Also, she wanted close up.
That's as close as we can get. Is that good enough?
Closer.
She wants to be closer.
Closer.
What can we do to get closer without stirring up the bottom? Anything?
Just try to jump.
We may not be able to get closer.
Yeah, that's the only. So we have everything retracted in all the ways, so we can't like drag ourselves in.
So we could take, well, they'll retract. I was gonna say we could take a piece and photograph it closer, but
If it's the maximum, it's fine.
it's the maximum.
Yeah, that is fine.
When I was fine.
We can try to just gently bump up. It's very hard.
Well, it's fine.
Fury. The fury
Austrogena.
looks like.
Somebody said the ophiuroid looks like Austrogena. Are the coral cutters on the inside there?
Yeah.
I think I narrowed it down to a 10-minute interval.
Your preference is the box with the crab.
It's really small.
Is that going to be a large enough piece?
How big is it? I can't see it.
It'd be nice to find one without the brittle stars all the way, arms all the way up to the tip.
It's fine, it's fine.
That's good?
That's good.
Okay. We want to put in one with the crab.
Are you worried about the crab eating the coral?
Or the crab escaping.
Or the crab escaping?
Yeah, the crab is escaping. Yeah, but I don't know what's in the bio box.
We need the bio boxes for rocks also, so I could put it in with the tubeworms.
Okay, yeah, better. Better than crab.
There might be a crab in there too, a little crab, but
Ah, the garrafeia.
you want it in 4B or 1B?
There is a shark. No, shark will come. Here. 4B with the snail. 4B with the snail and
Okay, so there's a small piece of coral in the manipulator right now. We think we'd like to put it in 4B. But not let anybody come out.
Watch if you run right through the bush towards come up above.
Okay, good one then.
You got it.
The coral. Somebody should write on the Falcor chat that the coral quivers fell off the vehicle, and we don't know where they are. Just put it on the Falcor chat so we don't get alerts.
Where are they from?
We don't know.
Okay, all of them?
Okay. I think it'd be great to do one more kind of pass over this mound, just so we have a sense of how big it is, and if there's anything we missed. We were looking over at the, I'm looking for live clams, and so we went over here briefly, just zoomed in to look.
And found nothing.
Yeah, but we didn't look very hard, so we'll just kind of drive around. So it looks like the tubes are all on one side of this mound. Which direction is that?
Which direction is that? West.
Yeah, so they're west, facing west. Maybe we could, I don't think we've taken a look at that cluster. Maybe we could just zoom in and look at the tubes there. There's a lot of dead clamshells.
Trying to work my way around the mound.
Yeah. There's a hermit crab.
Is this what you want to see on this side?
Yeah, and I might like to get one more rock while we're here and have good, one of these that would fit in the bio box, half a bio box. So that's fish, do you think that's fishing line right down there?
Not sure. I'll just settle it down.
Be worried, just in case. I guess that could be a tuber.
Yeah, I can't tell if that's fish or not.
It's okay. I just don't want us to get tangled in it. Oh, look at the nice skate. Oh, photo, guys? Yeah. So well camouflaged. Looks just like the bottom. So this group, I think this is a skate. They often will lay their egg cases at, and brood their young at methane seeps. In some cases, hydrothermal vents. We don't know why exactly.
Is there anything else you wanted to see here? Or do you just want to grab one of these rocks?
I would say one of those two rocks, but or one of these, whatever you think will fit, and it's easy for you to grab. Could go, it would have to go in bio box 2 or 3.
Okay. Grab one of the rocks here.
Lisa,
Yes.
Kevin wanted to remind you about the escape bottle.
We took them.
Oh, yes, so just to count. Yeah.
That'll be it for this site, yeah. We gotta save some niskins for bacterial mats.
Yeah.
Yeah.
Sorry.
So the more creatures on the rock, the better. This one's, do you think it'll fit? So let's get, you guys grab a photograph of the rock, please, or before he picks it up. So we're collecting carbonate rocks. I mentioned this earlier too because they host a wealth of animals. There's crevices, habitat for attachment, refuge. The rocks are autogenic carbonate made by microbes. They're made by a consortium of bacteria and archaea called anaerobic methane oxidizers, and precipitation of carbonate is one of their byproducts. When we collect these rocks, we're trying to keep them as a quantitative sample, so we'll take off all the animals, measure the surface area of the rock, if we can keep it relatively intact, and then we can get densities of animals. Might be a little bit crumbly. We could try a different one if it looks like this one is not going to stay intact. Don't know what that white thing is in there. Maybe one of those two would be.
Try and grab it with the one with the softer jaws in it. Maybe hold on to it a little easier.
Right, and the empty bio boxes are on towards that side anyway.
Okay, just give me a second. I'll scoot it over there.
Pachi, you want to talk in Spanish for a little while and just say what we're doing?
Okay. Bueno, estamos intentando tomar algunas muestras de rocas carbonáticas que albergan una gran cantidad de especies. Lo que se ve ahí son también pequeños corales de agua fría. Se ven restos de una cuerda de pescadores, otras especies. Es importante en este sentido conocer y ver estas especies de corales, ¿cierto?, que se han deteriorado también por los artes de pesca. Se ve sedimento que es relativamente oxidado, una pequeña capa de superficie. Más abajo se ve un sedimento más oscuro, negro, que indica condiciones reductoras. Se ven muchas especies que están alrededor de estos sistemas, muchos peces que utilizan estos lugares como refugio, aparentemente también de alimentación. Estamos a 382 metros de profundidad y en condiciones de oxígeno que están no son condiciones de oxigenación muy bajas, pero están apenas por sobre un límite que podría considerarse condiciones subóxicas.
loggers, please grab. Thank you.
You want that to file box 2?
That would be fine. We want to do not let anything grip on the other side. Let's keep it up. We're going to put it in A here.
Yeah. Right, yeah.
Tight squeeze. Fit sideways.
Sonny's an expert.
Awesome. Look at that.
There you go.
Oh, perfect. So, Biobox 2A. Carbon.
Now what?
13, 11.
Is it? Oh, okay. Alright.
Is it crack in the,
Yeah, yeah, right where the hole is, I see it, okay.
is it in the red part?
Yeah, it's in the soft part, it's okay, we can print somewhere. We don't want to
Okay.
be fine for the rest of this night.
Maybe we can just continue to drive a circle around this mound and then Elohio. You guys, I'm gonna pull the room. After we finish at this waypoint, we could go back towards 1, or we could continue because there's more hard grounds. And we could maybe find bacteria out there,
We'll
but I know
continue.
we want a core.
Okay.
You prefer to continue west. Could you ask the, Scott and, Jeff and Adam went to bed, right?
Yeah.
So, in terms of waypoints, I think we just go west of 4. But we don't have any more waypoints. So unless somebody, do you want to make some for us? Can you make us some waypoints that take us to these features?
Okay. So 1, 2, 3, 4, 5 is good.
Yeah,
I'm gonna come.
thank you. So I don't know, how big would you say that mound looked like? 3 meters across or something like that?
Yeah, well.
I mean, it's a fairly extensive, but the tubeworms are all clustered on the west side. Okay. It's a nice view of it, though. It's a good overview. It looks like a mound from this picture. Guys, just grab a mound screenshot, please. Yeah. Okay, so let me just show you. We don't have waypoints for them, but we're here, and there's more hard ground, presumably,
To the east.
to the east, right?
Okay.
And it looks like it's east, but up a couple of degrees, so maybe
We're working on getting waypoints for them. Adam's still up.
Okay.
So he's working on getting some waypoints.
I'll just get faced in that direction.
If we see bacterial mats, we'd like to stop and core.
Okay.
Anything of a decent size that can hold 3 or more cores. Eulogia, what habitat do you want your cores? There were a lot of tubes earlier in the mud between these mounds.
Around reducing sediments, maybe bacterial mats would be an option. For example, if this sediment we can put the Quisco should be fine as well. We have, some.
So you don't want dead clams or anything like that. I mean, we haven't seen any black sediment, no reducing sediment that's visible. On the way here, there was lots and lots of tubes of something, which I think we should maybe, if we see them again, we should get a sediment scoop or try to figure out what they are.
For example, here could be an option to make it like something.
You want a scoop here?
Yeah. Exactly.
Okay.
Here.
I don't know. It's pretty hard. I don't think
We could try.
we could try.
Because
That's
it's
true.
just surface
Actually, we should get a heat measurement before we leave this mound, just to convince ourselves there's no heat. Is the temperature probe accessible?
Where you want this heat measurement.
Here is fine.
Or here.
Anywhere you think it'll stick in the sediment, and it'll also help me see, because he wants a sediment scoop here, it'll help me see if there's enough sediment to scoop.
Just trying to get back near towards the mound.
All of this has
This is okay.
scattered carbonate, yeah.
Okay. All right.
It's going to be very hard. The question is whether there's actually, I'm thinking that what we're looking is just a light dusting of sediment over a rock right here, but we'll find out. Those shrimp look so peaceful down there, like they're sleeping. So we're going to do a heat probe, temperature probe measurement here. Sometimes seeps have hydrothermal sources from below, and we call them hydrothermal seeps. We don't think this one would, but it does also help us look at how much sediment cover there is over the rock and whether the sediments are coreable. So we'll find out if there's enough sediment to scoop.
Yeah,
If
that's
it's,
the second one. Well,
yes. Yeah. Just pick a good spot that looks. And if it's hard, then we won't do this. There's some interesting yellow sponge on the rock also that I haven't seen before. Can you tell how much sediment is there? Looks like there's a fair bit.
A few inches there.
Yeah, okay,
It's probably about 6 inches or so.
okay.
At least.
Did we get a temperature reading?
It's not really moving. It's looking at 7C right here. This is the temperature, just so you know. Right here.
Okay,
So he's got it pretty well buried in there right now. It's not really moving very much.
okay. Well, then we've confirmed there's nothing hydrothermal about this site.
Okay.
You could, well, it should be an event or observation that we just measured the temperature and it was not elevated. And it was 7 point, what was it?
7.18.
Yeah,
Pretty much what
yeah.
I'm seeing. That's what we're talking about.
It went up to, well, it was as high as 7.3 or something like that, but that's not doesn't look like anything hydrothermal. So, Eloia has requested a sediment scoop here. So we do know that there are some hydrothermal sediments at the Chile triple junction. Maybe 12, something like that, from a background of 4 or less. Sometimes when there's a lot of tectonic activity or subducting seamounts, they can serve as a conduit of heat that would come up the crust, and sometimes there's a meshing of hydrothermal and methane seep, hydrothermal vent and methane seep conditions, and we get taxa from both ecosystems co-occurring. That occurs at about 1,800 meters off Costa Rica at a place called Jaco Scar. We don't have any specific reason to think that there would be warm fluids coming up here, but it's always good to check.
Doug, I'll have some new waypoints for you in a minute.
This shorter one's probably going to be the easier one to stick in the bottom. If you can grab it. If not, then grab it. I'm assuming it's going in a bio box.
Yeah.
Okay.
You can probably put it in the bio box with the crab. Not too worried about the crab crawling in.
Okay, you're tracking that right now.
Yes, thanks.
There's a scoop.
Yeah, just the upper few centimeters of sediment's good.
Should get down so it falls in the bag. A little bit more than that?
Yes,
That's more.
please.
Okay.
Yeah, more, yeah.
Sure.
Can we get one more? Yep. So Erin, when we moved, this dive was going to get your background and your mat course. Do we take the background if we come across that first? Or you want to wait? If we don't see bacterial mats heading east, then I think we would go back towards points 1 and 2 that I worked on.
Either order works, as long as you record which Niskin gets fired off the background versus the push cord.
You need a Niskin over the background and a Niskin over the...
Yeah. So I guess if we could do the background last, so we could use one of those smaller Niskins, that would be better.
Okay. Okay, I see. So for those of you watching this scooping process, sediment scoops are a pretty basic kind of sampler, but they get larger volumes of mud sometimes than the push cores. And the goal is to pick up the small invertebrates that live in the sediment. Those could be worms, crustaceans, mollusks, there are many different kinds of worms, nematodes and nemertians and flatworms, subpunculans and echurans. We just don't know what's in here. But they're kind of a convenient way to get a significant volume of material that when it gets back to the ship, the sediments are sieved through a mesh that's usually on the order of 500 or 300 microns, so 0.5 millimeter. That's a good clump. Okay.
Happy with that?
Yep, thank
Okay.
you. Then the animals are sorted under the microscope and photographed and lodged for the collection. Sometimes they're sampled for isotopes to look at whether they're using chemosynthetic food sources. Somebody asked whether we're measuring carbon sequestration down here. Can you go to 1B? That has a crab in it that we don't want to run away, but
Sonny, you gotta move the arm to the left. Okay. It's hitting the vinyl box. So let me open it first.
so the only thing in there is a little brachyuran crab.
What's that? 1B? Yeah, the bag is going in 1B.
I mean, if you can fold over the top, that's great once it's in there. It's a long bag.
You can twist it up. Get smaller. And then start lowering it down there, twist it in a little bit in there.
Do you know the number on that scoop? Is there a... It's 2? Okay. So you guys had scoop net 2 loggers?
Start coming down. Catch up. Roll it in there.
so you got it, scoop net 2, sediment scoop 2, biobox 1B. And the habitat that was scooped was next to the carbonate mound. Yeah. Great. Okay.
Okay, now I'm good. I can give you more waypoints, and we're working on a new map. Although it's fun.
So the next waypoint would be to here.
5.
Okay. These are, I assume the waypoints are to these. Yeah.
Yeah, it's whatever Adam gave
Okay.
us. It is to these for sure. They're right here. We're working on extending the map.
Okay. So do we have another one to go to now?
Putting the waypoints in, and then you can decide if you want to go there.
No, we do want to go there. That's why we went and asked them for the waypoints.
Okay, so as soon as, I'm not going to interrupt them, but as soon as we bring them in, we'll be ready to go. Or if you have a bearing, they could probably head there now as I bring it in.
Okay. East.
I just need to bring in the waypoints.
We can probably start driving east very slowly.
Lisa, for future reference, do we classify the sediments as a geology or biology sample?
It's logged in geology, always. Under location, you put SN, scoop net 2.
Okay.
Right? Because there is no biology log place to log it. Both the rocks and the scoop nets go in the geology sample section.
Okay. I've got the data, sorry.
What? The rocks, where did they get logged?
Biology, but I will change in the future. The
Yeah.
rocks I have them in geology responses, so we have one geology.
Okay.
You did nothing wrong.
Could we zoom in on the little dark anemones, please?
Yeah, you're probably very good.
So these look a lot like Rathbanaster panachulids. Beautiful creatures. You guys, can you grab a photo of them, please? They are cnidarians, related to anemones. We have something that looks like this off Southern California at Seeps as well. It looks like they've got a contingent of shrimp guarding them. They're beautiful.
Lisa, could you repeat the species thing?
Well, it could be Rathbanaster. It used to be called Anthomastus, and they changed the name.
How recent was that change?
Does this look like Anthomastus to you?
Yeah.
Okay, we could call it Anthomastus.
No,
I don't know.
I'm just curious.
That's what Greg says in the chat, Jim.
What?
That's what Greg said in the chat.
Which name?
Anthomastin?
Okay, let's call it Anthomastus.
No, because if there was like a taxonomic change, that's really interesting. As it changes.
Oh, he said Rathbanaster is a sea star, so I got it wrong. Okay. Anthomastus. It's a panachulid.
Good luck. I'm coming over footage for the pilot.
There's another primnoid, like the one we sampled.
Are they a type of black hole?
What type of what?
Black hole?
I don't know if these are black coral. I think they're octocorals. So do we have our next waypoint yet, Ann, or no?
We don't have waypoints yet. What's that? Oh, okay.
So what do we think those little white specks are? Forams? Let's take a look at the white. It's either a piece of plastic trash or a bone. Probably a plastic bag. Yeah, more litter. So there's not a way to manually put in the eastward waypoint, is there? Another coral, octocoral.
Where's our new waypoint?
Go it up.
No methane here.
Nope, still just elevated background.
Look at all the creatures on that rock, teeming with life. Big shrimp and little shrimp interacting over something. What is it they're trying to eat? The tube of something. A lot of zoanthids, looks like hydroids, maybe some bryozoans. Ooh, it's a piece of fish. Look at that, they're sharing, amazing. BBC highlight.
It's the fox and the hound spaghetti scene with the one piece of spaghetti.
Yo, Dan.
I put a BBC grab at least.
Where's Dan? Where's Dan? BBC.
That's quite something. And then there's another little crab on the left looking on, trying to decide how to get into the action.
Could you F6?
Got a sponge in the background?
I'm pretty sure the big shrimp are harvested commercially around here. They look like they would be tasty.
Right.
Oh,
This guy
here
wants
here
to
comes
have
another
action,
one.
too. You guys
Let's
eat
see
more
what he
than
does.
Share.
He's feeling his way over to the.
Oh, it's a party now.
Oh, that's amazing. You think of me enough.
Ooh,
What?
he's trying to drag it away. The little one says, "Let me hang on here." So the question is, did the squid chop up the fish and
Right.
let the pieces fall, and then the rest of them feed.
This is my visual child right here.
It's interesting that the big shrimp doesn't seem to mind the little shrimp being there.
You're asking the chef or anything, deep sea biology.
Sorry, I was just bringing them up.
So you gave up.
I've had enough.
Must be full.
Could we zoom in on, oh, I was gonna say right where his head is, but I wanted to see what creatures were attached to the rock back there. Like, right there, I'm just curious what that is.
That's as much as I have.
Okay. Oh, there's scale worm. Okay. Could you pan up to that corner, please? Looks like there's a scale worm, a sponge, and some zoanthids. There's another big polychaete right here. Well, we could try suctioning over here. Let's see, Greg's watching if he wants any of it. Greg said we have a desmophyllum, so I don't know if these white corals would be them, but maybe we should try grabbing some of this. That's an amphipod, I think. Okay, is this a pick-upable rock by any chance?
Looks quite large.
What are we at? Oh, yeah, okay. Well, we could pick up the stalked parts, right? Just that with all the worms, I'm thinking.
We can try.
Well, we're interested in the white, which might be the desmophyllum coral, and the polychaetes that were crawling around on there, of which there's a scale worm and some other large polychaetes. It would have to go in a bio box. I'm not sure if those are zoanthids or what Greg was talking about.
Lined up perfect. Gotcha.
Okay, let's just try to be. Do you think there's room in 1B left after the scoop net is in there?
For this, possibly.
Yeah, let's do that so we save more bio boxes. Yeah.
Okay, so I'm gonna open up one. And see if you can set that in there on top of it. Yeah.
I mean, you could call this a hydroid sample, but it's got a lot of other creatures on it, so I was trying to get all the worms and things that were there.
Watch you pushing on box.
So
Slow.
it goes in there. Okay, good. Okay. That's great, thank you. Are we able to put in the next waypoint?
Is it?
It's in there, so we can go to it. So it's like 100 meters, and not
Closer to
150.
200,
200.
Where's your RV, new waypoint? Go up it up.
So we're heading to waypoint 5. The next few waypoints are highly reflective spots on the survey. We think we'll have hard grounds and maybe active seepage. Along the way, we'll keep our eyes open for any microbial mats, which would look like white patches on this brown sediment. Were you guys able to look back at CLOG and see where the microbial mats were reported early in the dive? I was not up here. But it would be good to know if it was at waypoint 1 or 2 or in between them.
We said they were at waypoint 1, they're between waypoint 1 and 2.
Okay. And presumably there's a marker put down
Yeah.
for them. Yeah.
I believe there are.
So we have a bottom with really high densities of small shrimp. There's probably a lot to eat down here. We're sitting below the oxygen minimum zone. And edges of oxygen minimum zones often have dense aggregations of animals. So these shrimp aggregations would be characteristic of that also. Usually they're places where there's a lot of food and not so many predators. It's a few clamshells. Clamshells are always a good sign of seepage if we see them.
to that where you saw the specking thing?
Not directly to be, we went down from it, but one to large. It was like what we were sampling, like 5 minutes later. And then that was where the next leg was. And we went back to the line and down to the continuous.
And that was just something like that, or like,
All of them. There was, the moment we hit seafloor, we wanted the 3 bacteria.
thank you.
Actually, do you want to talk in Spanish a little bit about just that we have a map of reflectors that we think are hard carbonates? We're going to go look for them.
Bueno, estamos avanzando hacia la zona de menor contenido de oxígeno, es más somero, condiciones subóxicas dentro de la zona de mínimo oxígeno. Se ve vamos por una zona que se ve relativamente plana, no se aprecian demasiados carbonatos, una gran cantidad de organismos y estos tipos langostinos que son importantes dentro para ellos esta zona como refugio. De alguna manera en esta zona se evitan mucho los predadores, como acaba de mencionar Lisa.
There's a lot of small tubes here. Yeah.
Estamos esperando encontrar una zona donde estén burbujeando o con mayor evidencia de las filtraciones de metano. Los sensores indican que estamos muy cerca o apenas sobre un nivel base o background. Necesitamos encontrar el lugar para probablemente parar y tomar algunas muestras. No tenemos evidencia de agregaciones de conchas calcáreas o almejas.
I'm tempted to take a push cord over these tubes. We could look and see if there's reduced sediments underneath.
No, sí. Estamos justo sobre el valor que se considera zona de mínimo oxígeno. Y a medida que avanzamos a zonas más someras y menos oxígeno, pareciera haber una mayor cantidad de organismos.
So we're looking at a bottom that's pretty well bioturbated. There's mounds and burrows. Often they're made by burrowing shrimp in Callianacidae. All the features you see are probably made by some animal in the sediment. There's an occasional sea anemone, the one we're passing over now. Those tentacles on the anemones have stinging cells called nematocysts, and they are basically microcarnivores, meaning they'll eat very tiny planktons in the water. Occasionally we'll see a purple stalked creature. I think those are umbellulas. They're cnidarians, the jelly, related to jellyfish and anemones. Oh, Greg said it's a hydroid, okay. Thanks, Greg. They're solitary hydroids, I guess, big polyps. Brachycerianthus is the name of them. These are the little stalked creatures that have tentacles at the end of the stalk. Someone in the chat points out that there don't seem to be many echinoderms here. Usually they don't like low oxygen, but there are plenty of exceptions to that. So we did see an asteroid, but very, very few brittle stars on the bottom. Escape. Maybe we follow the skate and he will take us to the seep. Or she. Be just about 20 meters from our next waypoint now. So we're looking for carbonates, hard ground, animal aggregations. Or any other change in the sediments that could be interesting. We always discover new things, so this is really the closest look anyone's ever had at El Quisco seep.
No se intenta llegar, ¿cierto?, a la zona donde hayan indicios de seeps o de afloramientos de metano que se forman rocas carbonáticas. Sin embargo, podrían no estar y haber condiciones de seeps de igual forma. Podrían no ser tan evidentes. Las condiciones de oxígeno siguen bajando.
Octopus. Slow down and just get a quick look at it. Please.
Hello everyone, my name is Eulogio Soto. I'm the chief scientist for this expedition, so I want to say hello to another principal investigators of this expedition. So warmest regard to Jeffrey Marlowe, who is the chief scientist as well of this species. So he's right now in Boston. And also my warmest greeting to Patricia Skete, who is another principal investigator for this expedition. So she's right now in Tromsø, in Norway, participating in Ocean Census taxonomy workshop. So we have a nice octopus, probably. Well, and also quiero hablar en español. Mi nombre es Eulogio Soto, jefe científico de esta expedición. Trabajo en la Universidad del Paraíso y, bueno, en esta expedición tenemos un grupo multidisciplinario de científicos y estudiantes de la Universidad del Paraíso, de la Universidad de Chile, de la Universidad Católica del Norte, pero también tenemos participación de científicos extranjeros del Instituto Scripps de la Universidad de California, también científicos de la Universidad de Boston, de la Universidad de Lafayette, de la Universidad Nord en Noruega, en Subria en Italia, y bueno, muchos estudiantes también que pertenecen a instituciones de Chile y del extranjero. Es primera vez que se ha podido obtener información directa a través de imágenes en este ecosistema de filtraciones de metano. Por lo tanto, es un hito importante para la investigación en Chile poder mostrar cómo es el ecosistema de filtraciones de metano, cuáles son sus características y qué tipo de fauna vive ahí. Así que un saludo para todos, disfruten la narración y la filmación y ya estaremos en contacto pronto.
The BBC camera doesn't resume the other camera. Oh,
I think we're able to. I need to understand, it's in there, yes, and I wasn't able to look up to 2 hours. So I need to understand how
Octopus often will come in and feed at methane seeps. We see the bottom
way better.
Okay.
Same
Way better, Doug.
species as
Thank you.
the Costa Rica seeps.
Trying to hold it steady here.
Yep, appreciate
Can
it.
I zoom in on a second?
They're very intelligent creatures. This one we obviously disturbed.
Yeah.
I'm just gonna let him walk out.
This is a Coelorhynchus
And I'm just gonna let him
macroid.
Oh, come on. Seriously.
They're not too happy about the lights that
Right.
are shining on them. Okay, are you guys good with?
Yeah, thank you.
Okay.
Yeah, I'm good. Another, yeah?
That's another one?
Yeah.
That's the
Oh,
second
wow.
one.
very close to waypoint 5, so what we're looking for is in the future. Could be hard ground. You have shells.
Oh, squid.
Down in there, we're not having a track down the waypoint for the last
360 or is there a sonar?
Cool.
Yeah.
Say again.
Is there a sonar that we can test see if there's
Right there.
You see it?
That's what else.
There's a couple of little pock marks out there, but no mounds or anything.
Oh, we found the mound, the last big mound, by going to our pool.
Okay.
I don't know if we're gonna do that, to check around here first. Romeo said we should collect that, but I'm not sure what he's referring to.
Oh, they kicked up through this tube, but I don't know where it is now.
I mean, there's a lot of tubes here that are very interesting.
She'll reduce one.
No, I think there's tubes.
Past SOI.
So it's a smaller feature than number 4. Rocker
Crawls in, I'll turn towards the south and see if I see anything yet.
Yeah, so Greg and I agree completely. We've been seeing lots and lots of tubes on the seafloor. I saw massive amounts of them this morning and guess carbonates. Things they're carbonates. So what do you think about push coring?
How we could try it.
This isn't the most dense tube area I've seen. What does he need seep? This is not necessarily active seep, but we're at waypoint 5, this spot right here. You want me to keep going past or go back to where the bacteria plants were? Because we have a shorter life area. Not go to that barrel that you're in. They're here. We just want to make sure we're not missing anything right here.
Yeah, this is pretty much traverse all the way to the front. Back and forth across it. So if you want, we can continue up to 6, but you can see that we've got features.
It's very smooth and 6 looks, and 5, 6, and 7 look very similar in the reflection map. Okay, I'm going to suggest we go back to waypoints 1 and 2. There was a lot of active seepage there. There was bacterial mat that can be cored. We need to get some cores. And I know, presumably, if we find a really good dense, well, could you zoom in just straight down here? This looks like a lot of tubes. This might actually be a good coring place. What do you think, Elohia? I see lots of tubes down there. And it's soft. And the fish is wanting to defend us. So those look, these shiny black tube are very Chaetopterid-like. Chaetopterids are interesting. They haven't been shown to have symbionts, although I find them at seeps and so on. Greg said look for 2 tentacles coming out of the tube. Do we see any tentacles coming out? There's something with tentacles out, but that doesn't look like Chaetopterids. And that's the solitary coral he was talking about. The purple one. I'm sorry, solitary hydroid, not a coral. Both cnidarians. But if we pan back over to where the tubes were densest, it's in the cloud. What do you think about push cores here? Do you want your cores? You here or somewhere else?
No, here, no, yeah.
Back at the. Okay, why don't we take 2 cores here? Over these tubes. Can you see well enough to do that?
I'm gonna work out a bit. Yeah, you can use the word for the ones on the left side. And you'll set the both out. One, set it, then we'll grab the other one up. And then set it.
You want one?
Take a picture of them both on the ground, so. Once you get it
So,
on the ground, we'll track the
the question is, should we take 2 or 3 total? I just want to have one where we can look at the worms.
She only one here, another one for Pachi, another.
I know, but how many cores do you think we should take here? Can Jorge use one of these? Or
one for Pachi, me no.
none for you? Yeah. We'll take 2. Try to, you okay with the worms?
I've got some jumper down also.
What?
Might be interested in getting one cord here for geochem, but I'm texting right now.
Who?
Jeff is in the Falcon chat right now.
Well, but you guys, you can't have 7 today.
Yeah, I know. That's why I'm asking which ones you would want.
can't shoulder, but you can help them up and down the hill. I can push the board down one time.
So if we can push them both in before recovering any, and over this dense cluster of tube, if you can find some patches where there's a bunch of tubes, that would be great. Yeah, like right there. Maybe. Back up a little bit. Yeah.
All right. Punch it in. Nice and steady.
Ahora estamos sacando uno.
There you go.
La zona
All
donde
right.
están
Let go.
pequeños tubos de poliquito.
Okay.
Poder analizar
Where'd you back out?
en el agua intersticial, en el agua de poro. Y ahora poder analizar soy sólida en sediments.
Try following you out. The board's there, picking out.
Concentraciones de sulfuros, metales, algunos estables, en las condiciones geoquímicas de los sedimentos.
And then next to it, somewhere with more, another cluster.
Yeah, and then all the way.
Yeah, that's okay. They're tall, might be hard to get them.
How's that looking for you?
Maybe a little further back. I can't tell. I guess those are fine. No, leave.
Back where you were, Sonny.
Here's fine.
Closer a little bit.
Here's fine.
There you go, right there. Right there.
Does Jeff want one of these?
You don't need it for the microbial. We just thought you might want geochemical data for animal studies, but that's up to you.
Well, Pachi's gonna do geochemistry on one of them,
Okay, great.
so.
I ended up using one of these. Awesome. Then we're all set.
Okay. So we get the picture. You guys frame grab, please. Oh,
So far.
that's a good picture of the setting.
Let me know when you're ready for us to begin.
You can recover.
Okay. I would grab number one first, because it's the second one.
368. We can't look at any for the animal? I thought one was for us, Greg and Lisa for animals, and Eulogio. You want one, you want me to take another one for Jorge here?
Well, before you pull that out.
Let me ask Jorge.
Does Jorge need cores on every dive?
No, only if we're not doing multi-core at a site.
Yeah.
Is it okay to pull it, or do you want us to wait?
Nope, you can pull them.
Okay.
Cores as a backup if we don't do the multi-core.
Okay.
Push cores are a hot commodity on this ship. There's lots and lots of lab groups interested in them. Some have very specific interests in bacterial mats or background sediments or different types of seep habitats. So we always have a discussion about how many cores, who gets what goes where. This is our first look at the sediments, actually. They're not particularly discolored, so we're not in any kind of heavy hydrogen sulfide environment. But it's coming out. Losing it. Okay, I think we've lost enough of the core that we should try shaking that. How much of sediment is left? Can you tell?
No, because it's dark.
Okay, let's just put it back in number one. We'll call it a short core. Can it go in fairly quickly?
Push out a little bit more. There you go. You got it. You're okay. Start going down one. Twist it.
You guys mark it down as short. I don't know how much sediment's in there, if any. It's hard to see. Maybe we can try shaking it out, punching it again. So when we have a core fail or sediment comes out, we'll often try to shake out the core, get as much of the mud off, and try again. Generally, the analyses being done need to have the cores intact and isolated, so we don't want to have mud from one spot contaminate mud from another. Looks like most of what's coming off this core is around the handle, though. The inside of the core looks pretty clean. All sediments are not equal. Some are easier to core than others. Some are very slippery and slide right out. Some stick in the core very well. It sort of matters what the grain size of the sediment is, how much clay.
Just go, get it started, and grab it again. You can actually do it if you put it like out like that. You can push it all the way in. Not close to us, but further away. You can lay it on.
But we still want to try for some tubes.
Yeah. See out here, out there.
And this one, it can go down and come up and go right back in the quiver.
Okay. You can go down right there, so. Yeah, there we go.
Just, you could recover it.
Now we grab it, don't grab it like this. Don't grab it, just grab it like this. So that you move your arm around. If you grab it like this, you're stuck holding it. There you go. Up on the handle. Get yourself some. There you go. Try that.
Sediment looks pretty homogeneous. Maybe it's slightly darker, a centimeter below the surface. Ketopterid tubes can be very, very long. I've seen them a meter long in sediments like this, and often the bottom will be in sulfitic sediments.
Use this camera a lot.
We don't need picture sky. We just need. You can see the tubes actually hanging out the bottom of the core, so the worms are longer than the core.
Just like that. Slide it on in there. Get it to a point. And then you can let go. Just tap it the rest of the way.
This also could be an interesting multi-core site.
Now just lift up, close the door, and push it in. You just want to see it seep. You don't have to push the tube all the way down through, otherwise it will go all the way down through. That's it, you're good. Okay, fork in. Grab the other one. Same thing. Okay, that's forks all the way in. Okay, you're set. I'm happy to just give you the options.
This one also had some tubes hanging out the bottom of the core. Gives us a sense of how long these polychaetes are. Topterid polychaetes are really strange, have a strange morphology with different body parts, with different shapes. They look pretty dense here.
Bueno, los tubos se aprecian algunos tubos a lo largo de los tubos. Eso es dificulta un poco hacer una geoquímica muy precisa. También, si se perturban un poco los tubos, también generan un poco de dificultad
Okay,
para hacer los
thank you.
análisis.
So we would like to head back to waypoints 1 and 2, which are to the west, I think. We're not convinced that we'll find more hard ground. And we have a group that needs to get the bacteria.
Sure. Do you have a preference on numbers 1 or 2 or?
Let's go to, Let's go to one.
Okay.
Should be, or if you, one is not quite due west, if you had due west, I think we'll get the right between 1 and 2, which is where we're doing.
So if you see the oil, we'll pick it back up.
Yeah, if you don't mind, can I fly the route we came to see if our coral quiver is laying on seabed instead of direct?
Yeah, but it must have been lost quite early. Well, it was definitely lost before we got to waypoint 4.
Right.
Or we would have seen it.
So this is where
The thing is that the way we came is not to waypoints 1 and 2,
Correct.
so you want to backtrack all
We
the
have
way.
an idea.
bridge RV.
Yeah, it's kind of like in between 1 and 2.
You think the coral quiver is between 1 and 2?
Say it
Okay,
again?
well, that's where we want to go anyway, between 1 and 2.
Bridge RV.
Would there be any visuals
Okay, copy
that
that. Let's come back to the west.
we could look at, like any cameras that would have recorded it?
They
No?
did, and they took a best guess.
So we had a rack of, how many? 8 quivers that are called coral quivers that are designed to hold biology samples, and that rack fell off early in the dive. We're not exactly sure where, but we're going back towards a more active site with bacterial mats and tubes, and we're hoping we can find the lost equipment as well.
Ok, estamos volviendo sobre el camino recorrido para encontrar las zonas más activas de burbujeo y algunas bacterias más, cobertura de bacterias. También se cayeron o se perdieron los recipientes para colectar los corales, así que no sabemos exactamente dónde, pero se va a intentar encontrarlos.
Are you gonna go back down to 3 or just go straight across?
Where they have it marked is kind of like straight across from where I'm at, so I was gonna try and cut right towards the middle there.
Okay, great. So like most seeps, it's not just one spot, but it's patchy areas of seepage spread out with sort of background conditions in between. Oh, that looked like a Dumbo octopus that just went by on the ground, on the floor. I know there was a big patch of tubeworms found early this morning before I was up, along with some bacterial mats. So we're planning to go back over to that area no sampling was done on the first watch as they were more or less surveying. But the methane peak was in that area as well with the tubeworms and bacteria.
Se está tratando de volver al lugar donde se encontró máximos de metano que se detectaron con los sensores para tomar muestras de sedimentos para analizar la geoquímica, también la actividad biológica, la microbiana.
Okay, let's ask the loggers. What is your favorite creature that you've seen today in the last 3.5 hours?
That's a great question. I don't know, Erin. What are you thinking?
You can each have separate favorites.
I am partial to the tubeworms.
Those were amazing. I haven't seen them before, like in live streams. On a live stream.
Great. So we have a vote for tubeworms. Anybody else? Erin's, you have the same?
Yeah, I am partial to the tubeworms.
I was very impressed by the shrimp predation and
Yeah.
the sharing of the fish carcass.
That was really cool. I've also never seen so many squid together, so that was really exciting.
Yeah, I thought that was really cool. All the Humboldt squid, being able to see 3 or 4 of them in one view, pretty special. Okay, pilots, you have a bit up here too, Locke. What are your favorites?
I always like octopus.
Squid?
The octopus.
Yeah,
and squid was very
octopus.
cool. Yeah,
Octopus
I've never
and
seen those
squid.
before. Those Humboldt squid were really awesome.
Great.
Yeah, the Humboldt squid actually hunted. That was impressive.
Watching the Humboldt squid feed and hunt. Oh, this is a carbonate mound. Could we just drop a waypoint? We don't have to stop. Just to note that there's some carbonate there. Oh, are we back at 4? That's why.
Yeah.
Maybe it's the same place we were before. I don't know.
What about you, Lisa? What's your favorite
Ooh.
animal for today?
What is my favorite? I like the fuzzy rocks, full of
I'm with you.
hydroids and forams and corals and snails and crabs. I like the whole thing.
I mean, assuming we caught some anaerobic methanotrophs, then the anemone would probably be my favorite. But I'm not sure that's charismatic.
They might
for
be in the
audience.
rocks.
They might be in the rocks.
What would you like to call that last marker? The last marker that we dropped. What would you like to name it?
The
Just-
place
let's
we
just-
record?
Just now, where we just passed over, you said
Oh.
drop a marker.
I think we were at waypoint 4 actually. So we don't have to call it anything else. I think it was waypoint 4. If this is correct, are we?
Okay.
Yeah.
We're pretty close to it, yeah.
But I love the octopus always. I think they look like Grenelodoni octopus, same ones we had in Costa Rica. Seep, they hang out around the seeps. But I bet Anna's favorite are the octocorals. This place has something for everybody. The cat sharks are cool. Oh, a clam patch. Probably not alive, but there's some clams.
Pequeños parches de carbonato. Parecen ser restos de
This looks like shell hash, pretty much. Yep. Is that bacteria? Or that's probably forams. All those little, see the little white spots that make the sediment look gray, that's either bacteria or forams. Might be bacteria, actually. Okay, we should mark this as bacterial mat.
Aparentemente estos son parches de bacterias. Es lo blanco que se ve.
An event or photograph or something like that. Erin, I'm going to assume this isn't dense enough for you to want to sample it.
I would prefer.
Okay, we'll keep going back to 1 to 2. But that was more or less at waypoint 4. It was just a spot we hadn't seen. Another skate. Yeah. Two of them in one view. That's pretty cool. We have a site, a methane seep site in Costa Rica called Skate Park. You've heard of it?
Yeah, we were in Costa Rica last year.
Yeah.
I don't know if that's
Been a
been
skate park?
It was named for all the skates that hang out at the methane seeps.
It was Octopus Odyssey, wasn't it, Lisa?
This was from a 2017, 18, 19 cruise.
I think we may have.
But we actually
revisited
named it
yeah.
in 2010 or something like that. We've been back to the same places a lot.
It was still full of skates.
Yeah, it's amazing. They're very loyal to their brooding grounds or feeding grounds. Look at that collection of different size shrimp. There are probably 3 species there. And the mounds are really interesting. The light-colored sediment has been pulled up from below by some burrower, maybe a shrimp. A Calian acid shrimp. They look like little volcanoes on the sediment surface. So this is new terrain that we're covering right now. We're moving between waypoints 4 and 1, and we haven't actually seen any of this bottom yet on this dive. So it would be okay for the loggers to just more or less document whatever it is that they see. Skates, shrimps, anemones. solitary hydroids. And then some cat shark and dog shark type. Lots of cats and dogs. Here's a squid, maybe. We want to sample around 1 and 2 in there anyway, so we can go hunting for the coral critters. Earlier this year, we had an Alvin dive series off the Aleutians, and one of the swimmers that helped launch Alvin lost his weight belt. It's a big ocean. We got down to the bottom and started our track, and we found the weight belt. And recovered the weight belt. Yeah. I mean, talk about a needle in a haystack. It's like finding a weight belt on the bottom. And we were at 4,900 meters.
Oh, wow.
Which makes it remarkable.
Yeah, for sure.
Biologists and ecologists and systematists. So very, very multidisciplinary. There's a whole bunch of dense tubes again down here. Probably catopterids. There may be some other things here. Yes, microrids. Coelorhynchus was the name Maritza gave us.
What's your max distance that you from the launch recovery point? You did like how far away you are? Far away. So you feel the touch. You're kind of near the limit, you'd say? Pretty much. Your truck.
How are you gonna, grab them? Oh, here comes the squid. There's a lot of them. Look at that. 3 or 4. Oh, these are rocks. What is this? Or is that just sediment kicked up?
From the squid.
The squid. I see. They sure are big. They're like a meter and a half long. They look well fed.
Right.
And they're curious. They want to see us.
See ya.
Go to coral covers, search.
Yeah, that's one, but yeah.
And then.
Bueno, como se indicó hace un momento, fue una expedición multidisciplinaria de varios países, de varias instituciones en Chile, en Estados Unidos, también en Europa. De los científicos a bordo hay microbiólogos, ecólogos, geólogos, geoquímicos.
Looks like you got for one, looks like 2 you got.
1 and 2 have been taken, but all the others are empty. So we're looking for bacterial mats. That's what they want to sample, and we're going back to waypoints 1 and 2, where I'm told there's big bacterial mats between waypoints 1 and 2, and the coral quivers may have fallen off there. No. Are you? I don't eat squid. But one of these would feed the ship for a couple of days. We are going back to one between 1 and 2. I think that's where there's bacterial mats. And that's what we're looking for. There's giant tubeworms somewhere over there. And coral quivers fell off the vehicles when they think they might be because they were reviewing the video we are traversing, so just so you know what we've done. We went, I wasn't here, but the dive started at 1 and went to 2 and went to 3, and I came in about here. So then we went 1, 2, 3, 4, 5, and now we're heading straight back. So this is new terrain, and hopefully we'll end up over here, which is where the bacterial mats and tubeworms are supposed to be, somewhere between these two, or maybe at. You can check the logs, sea logs to see. So they didn't do any sampling until we got to here. And so this is your, got 3 spots left. There, as you saw, there's a lot of doubling up of stuff in here. And since, unless we find coral quivers, you know, you can use one of these as the biology box. But the tubeworms are in here. Yeah, I'd like to get more rocks. We have 3 that I didn't, sure. Yeah, and we fired 2 niskins, but they want, so the browse lab wants 3 push cores and a bacterial mat and 3 background, but they didn't want to take the background till they knew they got their bacterial mat or something like that. And Eulogio needs 5 cores in one place today in a bacterial mat. And there's other people who need cores. So I would fill up, if you get to active seepage, fill up the core. Take a lot. I should draw a circle. These 2 were the Ketopterid field, but there's actually dense tube fields every so often here, which are very interesting. I would have liked to have taken more, but we need to save the cores. I am just making notes for myself on this one, because we're not the log keeper, of places where we're doing a bunch of sampling. Okay. So I have the lat longs and the depths, but Pachi should have. You have a pen? Something to write with? Okay. So, somebody take a screenshot. There's huge clusters. You want to see mine? You can fill it. Then I'll borrow this just for a second.
Pero falta el 4. ¿Dónde está el 4 acá?
So these 2 are taken. All of these.
Ponle una X aquí que yo sé que están ocupadas. Y esto que
Son estos 2.
y luego lo
No,
pones.
no.
Y luego la 8 y la 3.
This?
Ah,
Got
BB2,
something?
sí.
Sí.
Y luego la Niskin Bottle
And
2,
then section
una,
8 and 3.
section 8 and 3. Y luego la Niskin Bottle 1 y 2
1 and
están.
2.
Ya,
Yeah.
hecho.
All right.
That's
Hi,
it.
everybody.
Okay.
It's Greg Rouse here from Scripps Oceanography in San Diego. I'm relieving Lisa, who's been on for Lisa Levin, a colleague of mine from Scripps, who's been on the lead here for the last 4 hours. We're just doing a shift change of pilots and people, so who are logging, and my co-lead, Anna Adamo. A little bit noisy. We are off El Quisco, which is a little resort town just near Valparaiso in central Chile. Offshore, not too far, a few miles. We're in 350 meters of water. And we're pretty excited. This is a very cool area of methane seeps and has never been explored by ROV. People have certainly been here before sampling, so it was known as a seep. And in fact, there's been species described from here, such as clams, and we haven't actually seen the clams yet, so that's one of our goals, is to find those. And this morning we went over the site. We've done some sampling of mud, grabbed some tubeworms, which are a particular interest of mine, and I'll talk more about those when we see some more, and other kind of fauna associated here, plus rocks, and the rocks are carbonates, so calcareous rocks that are actually a product of methane activity that's then broken down by a consortium of microbes called bacteria plus archaea, and that results in carbonates being formed as a byproduct, and that leads to reef-like structures that lots of other interesting animals can then live on, as we've already seen so far today. We're just traversing back to where we initially started today, where we know there was a lot of bacterial mats and tubeworms, so we're trying to get there and we'll do some more sampling and get some more imagery and share a bit more knowledge of what we have about this place. This is the first seep we've really found on this expedition. We were up north the last few days, Limari Canyon. We explored there for a little while but decided there was no real... we thought there were seeps there, there's evidence of seeps there, but we didn't really think it was worth the effort to really look for them. Would have maybe taken us days when we knew there were seeps further south, so we've headed down here. And we're likely to explore this seep for a couple of days. The oxygen here is pretty low. The oxygen minimum zone in Chile is lower, at a shallower depth than, say, off California. And we just saw then a wonderful squid, a Humboldt squid, Dasyticus gigas, come across our screen. Remarkable predatory group of squids, grow quite large, and you see them every now and then darting down to the bottom to grab an unfortunate fish on the bottom. And they often hang out on the margin of oxygen minimum zone, so we weren't surprised to see them here.
Hi, Ben. How are you?
Wunderbar, I haven't seen you. No, that's the view.
Hola a todos, soy Ana María Damo, vengo de la Universidad, la North University en Noruega, en Buda, y ahora estamos con Gregory aquí en la Mission Control para buscar estas infiltraciones de metanos y de gases que están aquí en Chile. Hemos empezado en Limari, Canyon, y no hemos tenido mucha suerte, entonces nos bajamos aquí en el Quisco y esta mañana efectivamente hemos tenido muchísima suerte, hemos encontrado las infiltraciones y ahora estamos mostrando. Hemos ya mostrado muchísimos organismos marinos, es muy rica como zona, aunque no parece a primer lugar, pero es una zona muy importante, muy rica también para la tipología de fauna ítica y de invertebrados que hay. Personalmente estoy aquí para recolectar agua de mar, la que está más pegada al fondo, al fondo marino. Esto para mostrar lo que es el ADN, o sea, el ADN ambiental, y ver si efectivamente lo que es la señal genética que encontramos en la muestra del agua es la misma que se encuentra durante los videos. Entonces será un análisis genético y un análisis visual de todos estos buceos, así que a ver si tenemos suerte.
So that was just some plastic bones.
No.
Expect to see some bacterial matter, mounds, covenant mound, and tubeworms coming up pretty soon.
What's under me?
But Sophia,
Yeah.
it did make it to the bottom, right?
Yeah.
Okay. I'm gonna start getting production. I don't see anything going on, so.
Jules, when it comes to the entire dog, or the tracking of the entire
No.
I mean, we can't. Would that be possible? Because we're just retracing ourselves. Yeah, can you?
Bacterial matter in the mound, juveniles. You see this thing, this one, somewhere along between 1 or 2.
Greg, it's about halfway between us and waypoint 1.
Yeah. Okay. Starting to see some signs of clams, bacterial mounds. We're going to see if we find a nice big liver of bacterial because we've got quite a lot of push cords to the floor.
Listo.
Really starving and I moved away from it.
Update again.
This one. Yeah. Okay.
Just put a mark on that.
Right.
Just come back to it. Go forward. Keep heading towards one. See what we see.
Hey Greg, we've been getting rising methane for about 5 minutes, by the way.
Okay. So,
I can break into any rock. Okay, no worries. And then you can rename the marker by sliding up from the bottom and dragging, yeah. And then your marker. Bacterial mat.
now it's like it's easy to carbonate. That's as well.
Yeah, it's a transparent.
Yeah.
Right.
Amazing.
This is a transparent.
More appears to be resting from the tubeworms. It's quite amazing at this depth. We used used to seeing something like this at depths like 1,800 meters. So Austrogena. This is quite an assembly. So we'll have a look around. Get some nice close-up imagery.
I thought it was just there.
Got a marker? Yeah. I do actually want to but the thing, no marking there. Yeah. So we can find it. Sure.
No, I know.
Can I push forward? Yeah. Can I push forward? Yes, please. Okay.
So we've come over the top of that mound, we're on the other side now. And we'll probably go back and explore that pretty carefully and maybe try and make a 3D map of it using photogrammetry. Looks like a pretty ideal kind of feature to do that on. So the white patches you're seeing are most likely sulfur oxidizing bacteria. The methane's already been broken down by that consortia of microbes I talked about, some archaea and bacteria, and they oxidize the methane, and hydrogen sulfide is released as part of that process, and then that is available for other bacteria to use. And so in this microbial mats there'd be a whole consortium of microbes and quite a team of people on board that are really interested in documenting that.
I'm just going to go a little bit towards the waypoint and then I will complete turn around.
Okay.
And follow the track. Take one look here.
So we'll head back down to 2 because we're really looking for the quiver.
Yeah.
And then we can go back to that mark. Yes.
Okay, I'm gonna head for 2 now. Better.
Hey, Bridge, this is RV. I just moved the waypoint again.
Update, thank you.
So we're just going back along our original track, starting early this morning. Since in that initial survey they didn't really plan on sampling, so now we're just checking for the best place for us to do some push coring and grab some more samples. got a few more hours on this dive. In the few days that we have here, we want to sample as much of the biodiversity as possible. And that will be used to compare with seeps we find further south, deeper. After this we head to Concepcion, and then we'll explore some canyons along the way, and then all of this data will be compared with seeps we've studied further north, off Costa Rica, Oregon, California, even as far north as Alaska.
Como dijo Greg, estamos volviendo atrás en el transecto original que hicimos esta mañana para buscar estos signos de metanes que hemos encontrado y hemos visto ahora como unas alfombras de bacterias blancas como si fuera un estado sobre el seafloor, y efectivamente esos son lo que estamos intentando buscar y mostrar también, y la comparación de esas filtraciones de metanes que hemos encontrado por la primera vez aquí hoy va a ser una comparación con lo que han encontrado también en Costa Rica, en Oregon y en Alaska, y esta es una comparación biogeográfica muy interesante también en futuro.
Retracing our steps.
There's a question in the chat about where does this methane come from? It's in the crust, and that'll come out eventually, and that can be worked on quite deep down by the microbial activity. And the other source of methane can be from things like petroleum products. As for this source of methane, I'm not quite sure. I'll have to consult my other colleagues about that. We're still doing a bit of a run down our initial track to find an ideal place to sit down and do some sampling. We found a few mounds in the last 15 minutes. We've got a hagfish in the frame. This feature here is mostly carbonate, probably covered with a bit of sediment. And then there are lots of little white squiggles, and those are the tubeworms that I've been talking about, that are called Vesicomyid.
Yep, there it is. Yep.
Okay.
Yay.
We've been also looking for something that fell off the ROV earlier today. And we don't want to leave trash on the seafloor, so we're very happy we've just found this.
And what I'm going to do is I'm going to
So what you're looking at is 8 tubes that were attached to the side of the ROV, and those are sampling tubes. And we would have used those for putting small snips of corals or smaller animals directly into them. And when we went to use that earlier today, we realized it wasn't there. So we figured it had fallen off and have retraced our steps, and so we're happy to say it's here.
just get all of it. That way it's not the room, all our sampling and everything. If we can get more time for us to come get it before we recover, that'd be great. Okay. Yeah, just get a really good marker on it, okay? Good job.
So what we're going to do is leave it, because we know where it is now, and we'll come back because it could interfere with our sampling for the rest of the dive. And we'll just put it on the ROV and bring it up later.
We're 1 meter grid, so we can 1 meter.
1 meter sounds good.
El primer y afortunadamente lo hemos encontrado, así que también porque no queremos dejar nuestra basura ahí en el fondo marino. Entonces ahora lo que estamos haciendo es localizar perfectamente el punto y luego lo vamos a recuperar más tarde. En el mientras vamos a seguir mirando y mostrando lo que necesitamos mostrar, por ejemplo con el push cutter, que son estos tubos que van en el sedimento, recolectan sedimentos y luego verán analizados más adelante por parte de nuestros colegas geólogos y microbiólogos. Y Greg también estaba explicando antes que estaba respondiendo a una de las preguntas que estaba en la chat sobre de dónde salen la origen de estas infiltraciones de metanos. Hay diferentes orígenes, puede ser diferentes razones, no se sabe muy bien la razón de la infiltración de metano aquí en el Quisco, así que se tiene que hablar con los colegas y para averiguar efectivamente la verdadera fuente, pero parece ser que puede tener, como he dicho antes, muchas razones. Uno puede ser el movimiento de la costa terrestre, entonces sale directamente de la costa terrestre, o pueden también tener otras fuentes. Así que ahora vamos buscando lo que dije antes, una suerte de alfombras blancas que son bacterias, y ahí queremos buscar, mostrar también push cutters en el sedimento.
Thanks, Anna. We're going to head back to where we saw some big microbial mats, and we're probably going to put in about 10 at least cores to keep the microbial people happy and busy tonight. So we'll look for this big white microbial mat, sit down, do some coring, and then we'll probably go look at a mound and do some more sub-sampling there. We'll want to grab pieces of rock. Lisa Levin will be, along with other animal-oriented people, looking for activity in there, but the rock itself will be used by our geology team. can see line. This part of this area around El Quisco is a marine protected area, but other parts are actively fished, and there are commercially targeted seafood here, the shrimps you've seen, and the Humboldt squid. So we've come across quite a lot of line today, which can be a hazard for the ROV, so we're very careful about it. Other parts of the El Quisco area are marine protected areas, and potentially once we've mapped and looked at all of this area, this little methane seep could become a valued site as well. Quite a long stretch of rope there on the bottom that we will definitely be avoiding. First, we'll come back to here or whatever. First, we'll look for a nice big muddy mat. So we'll go for mud first. Yeah, these big white mats. So I'm trying to look for a big patch of white mat. Pencils. They're all patches. Yeah, they're all patchy. We'll try and find as big a one as possible.
You wanna? I think the first mud had a lot of patches, right?
Yeah. Let's go to that.
But bubbles, right? Yeah.
Okay. There's some line. You might have to go to the last one.
Okay. I'll move the vessel back this way. Is that right?
So we've mostly seen white mat. I've seen one patch that was also yellow, and we'll be
Update, thank you.
trying to keep an eye out for that.
Dead ahead of you.
So you got lines on the ground to that? Yeah. It's white on this.
You wouldn't want to settle with this line.
I agree. Yeah, we don't want to sit on top of
We
the
won't
line.
go near the line.
Yeah.
Yeah, let's find a better one, a safer one.
What's up? Yes. Just go dead ahead here.
Lots and lots of tubes here. These are Vesicomyid tubeworms, and they were only discovered in 1969, actually, just off Mexico. And they are part of a group that had been known for about 100 years, called coelacanths, but these Vesicomyid are quite large. You can see the tubes are 50 to 100 centimeters long, and hopefully we'll settle down and get a nice close-up look. You can see the patch just going underneath now, little red heads coming out, and those worms actually don't have a gut, so they're feeding, or they're actually farming bacteria in their bodies. Those sulfur oxidizing bacteria that you can, not the same ones but similar, that you can see forming that mat down there. So we'll be checking. There's some bubbling. Yeah, thank you. So the bubbles indicate methane, active methane seepage. There's probably a lot of methane percolating all through this sediment here. But we have a gas sampler on board, so at some point we'll probably get that out in the next day or two to try and sample some of those bubbles. This whitish material is probably clam shells, dead or maybe some alive. There's more bubbles, so this is a nice active area. The grey is more microbial activity. And we're coming up on a big mound. I still haven't seen a good one, maybe on the other side of the mound. Yeah. We'll be taking some of these tubeworms and doing genetics on them. A few years ago we named a new species from Costa Rica, and that was at 1,000 meters of this is a genus called Lamellibrachia. And we named it after Don Walsh, a famous deep sea explorer, one of the first people to the bottom of the Mariana Trench. The other species of Lamellibrachia in the Eastern Pacific is a deeper known one from about 1,500 meters or greater. And that was named after a pilot of a Navy submarine that first collected Lamellibrachia off San Diego, northern Mexico back in the 1960s. So both of the Pacific Lamellibrachias are named after a nice bacterial mat to sample.
I don't see anything in the way. So I'm going on now. I don't see anything on that. It's more on the other side.
Should we head back south a little bit? That's where we first saw the mats.
Back south?
Yeah, along the track. Do you have a mark on there where we first saw the mats?
Yes, I did a full 360 on this.
Yeah.
That would go right here.
It's probably...
Or would
It could be all pretty hard under this.
I had two Levi's with a big one.
That's all right, yeah.
There's a lot of clam debris here. We haven't seen any live ones yet, but live ones have been found here. And named by Chilean and Russian scientists back about over a decade ago. Called Austrogena nerudae, named after Pablo Neruda.
Pretty much on it. It's this whole
So,
map goes to his mouth.
I'm really hoping we do find that.
I really did a 360 around. I did a 360 around.
Could you zoom in on this, please?
Go ahead and zoom in. Okay. So it's fine. Let me get you closer. Okay.
Yeah, it's a basket star.
Crinoid. Basket star.
So that's a brittle star that normally just have 5 arms. And this one has 5 arms, but they branch. And they often perch up high to catch plankton. And the arms branch in almost a fractal-like pattern. We're looking at it side on. seeing lots and lots of vestimentifera tubes, the lamellobrachia I've been talking about with their little red heads coming out. So that's probably a group we've seen further north. It's called Gorgonocephalus, with that branching pattern. And those arms have little sticky hooks on them to catch plankton like copepods and other things. The mouth is in the center of those arms. We're looking at it side on, so it's a little hard to get the anatomy.
Get your picture.
Okay, that's good. Thank you.
Okay.
We will later. Coca-Cola. Would head south. That's where we saw the mats.
It's probably the right treasure. Roger. Bridge, RV nav, you got a new way.
Update, thank you.
This is a feature about 10 to 20 meters across and a little bit raised, and I'm pretty sure we're going to take the chance to do photogrammetry on it, so the pilots will run over the surface in a mosaic pattern, and then we'll hopefully generate a 3D model, which will be very handy for future study. But not right now. First we're looking for that elusive bacterial mat so we can do some bush coring. Okay, here we've got some mats coming up. It's not quite big enough. I want a bigger one. Maybe we'll just have to do we might do some in one mat and then move and do another mat. How about we settle on that one? Good enough? Yep. There's always this tension between keep looking for a better place or settle down and sample once you can see it. So what we'll do is stop here in a smaller mat and put a set of cores in and then move to another mat.
Port side, we're doing push course because I have to do push core 3 minutes. And then push core 3 would be the next push core. So it's already push course.
Yeah. Any, if only taking two.
Yeah.
So any of these. Your choice.
How many do you want here?
Let's see how many we can put in. But we want to go into the mat,
Right into the white
lay
side?
them out, and then pull them all at the end.
Draw like a straight line across.
Anywhere in them,
Anywhere
just
in them.
inside them.
Okay.
And we'll see how many you can fit.
20 lines ago, we shot this one here.
Okay.
That's sufficient.
So Ben's gonna, pilot Ben's gonna set us down, we'll have a look. And then this co-pilot Levi is gonna do sampling for us.
Lo que estamos haciendo es, hemos encontrado una alfombra de bacterias blancas, la que veis en la, adelante del radar. Lo que estamos haciendo, el piloto Ben está intentando posicionarse en una situación cómoda para poner los push cutters en el sedimento. Esos instrumentos que conseguimos para recolectar la muestra de sedimento, una columna de sedimento, que luego verá analizada sea por los geólogos que los microbiólogos que tenemos aquí en el Falcor. En el Falcor 2, perdonad. Y nos estamos acercando, estábamos buscando una alfombra más grande, pero nos vamos a empezar mostrando esta. Niskins, yeah, two. Yeah, the push cutter are for marlow. Entonces, Niskin bottle 1. What?
Let's just, sorry, but before we sample, we want Niskin. Okay.
Alright, so when you retract, you should see a little blue piece wiggle right before it launches. So you gotta very gently retract, yeah. You should see a little wiggle right before it goes.
So what we're looking at now is an array of buttons that are connected to Niskin bottles, those are water bottles. And we're trying to get a water sample above this bacterial mat. It's a 5-litre bottle. And there it goes. So that was number 3.
Okay, is that one?
Just the one.
Just one.
All right, now
Does
we
this have a
can,
subtitle?
now we can push go.
Okay. Yeah, so that's your. Alright, so I didn't make it right, or I did modify it, so.
What was that?
Alright.
Oh, no, we'll stand by. Yes. I'm gonna write. Oh, no, never mind.
Yeah. Practice here.
Could we get a nice look at the map first as well? Sure. Just have a look at the surface, see See if there's any creatures crawling around or any other interesting features about this map before we start pushing cores into it. Could you zoom in even more to see if there's any? Just trying to see if there's any little animals associated with this. Often there's lots of animals grazing on the... And there's little red tentacles coming out. Those are actually the gills of what's called an amphoretid. It's a kind of polychaete. And often there might be little snails. I don't see any snails, but we can see lots of little red gills coming out. So that's a kind of worm that are very common at seeps called amphoretids. They're kind of a little spaghetti worm creature that has tentacles, probably grazing on the bacteria. And we can see the shrimp were eating the bacteria as well. So these are aerobic bacteria that are sulfur oxidizing and using that hydrogen sulfide that's coming up out of the sediment. All right, thanks. Okay, let's. Oh, even the crab's eating the bacteria. Yeah, interesting.
Okay. Yeah, So we've already taken 2 cores today, numbers 1 and 2. Now, probably take 6 here. We'll see if we can fit 6 into this little map. Clear to me how many mapped cores we want from this plan. I can't tell. So I can see 2, 3,
4, Marley 3, also back.
That's background.
being a different mass from Marlow. Yeah, I think it's
3, 4, 5, 6, 7.
okay. But in 2 and 6, okay, we just okay. We try. Greg, we will try to do this. I will make a map of that. Yes.
It's 7. That's why I was looking for a big one. This not in this area, 7. When they get 7, we could, let's see what looks reasonable, but let's do at least 3. No, 3 for sure.
Just like the scalpel, take all the way up, and then just go 90 next time. 75, 45.
Okay, you get that view?
Yeah.
And sit.
Go to the left side, we're going to be showing the next goal.
Is that good for you? Gregory?
Take a spot.
Yes, that's perfect. Thank you. Zoom in on this.
Yeah.
It's easy. Don't drive it one shot.
Oh.
There's a crust. Once you get to the crust, you can go down.
Okay.
Don't push it too hard because now we're moving forward. Just slow, steady pressure. But back to the crust.
Yeah.
Can I come down that?
Sure. So there's likely a carbonate, some kind of crust here in the sediment, and that's stopping the core, which is not ideal for us.
They can move it already.
You are, I'm pulling back.
Ay. Maybe.
Pulling back and thrusting back. Thrusting down. Going down. Yeah, a little bit more. Might be going at an angle. It might be hard ground, right? Yeah, this might not be a good place. Can we have a look at it, Ivan? You could pull it out, we'll see. Pull it out easy. Okay, zoom out, Sophia. I think it's falling out. Yeah, okay, we won't keep this. You could shake it out. Okay. I think we'll move to another one, see if we can get a better option. It's in there good. Yeah, it got very disturbed on the top there.
Yeah, it's like a hard crust.
Yeah. Normally there's a layer of crust, then after you get it, then you want to say punch it through, then you chop it down.
What do you want to do next?
You might as well hold on to that. Yeah, let's go to another one. Okay. Let's hold on to that. Freeze it. Yeah.
Yeah, alright. That's frozen.
Thanks, try the one just over there. Roger.
Yeah, it seemed like once it was like a hard crust, and once I got through with the RV route, then I could just strip it.
So we'll settle down at this next mat and try again. The concern would be there might be quite a lot of carbonate here, so we might have to move on. Let's find another mat. Lots of crabs here and shrimps. Lots of shrimp, fish as well. The Chileans are not sure what that fish is, so we might try and sample one of those. Those are true crabs. You can see they have 4 legs for walking.
Right? Alright.
How's the method? It's dropping. It was really high at the big mound, which is where we had the high signal this morning. And once we came off it, Greg, it's just been going downhill. So.
And where we saw the bubble. There. That's the spot.
Stay down. Kind of rocket as I go down, you know what I mean? Yes. I can move slowly, tolerate it. It's pretty shallow, right?
Yeah.
Yeah, I feel like as I'm pushing down, I'm just moving out. That's all you're doing. I feel like I'm not penetrating into the ground.
Peter, are short calls like this useful or not? You still use it?
Yeah. So we have to keep the bacterial mat intact or
It's
undisturbed as possible.
It's intact right now, it's shallow.
Yeah.
Yeah, you could leave it there, Levi, and put out another one, and we'll just see if it'll settle. So we'll,
Alright, I'm gonna open it out later here.
yeah, you can put. We usually put them out in a set, and then we cover them.
Is it possible to get a suction sample of one of the crabs to do fatty acid analysis?
Yes.
Thank you. Maybe on the suction.
Four?
Yeah.
Peter, do you want to see how one comes out? For deciding, or we'll put another way in and just see how it goes.
Yeah, sounds good.
This one I think I'm gonna go for 45. So, yeah. This doesn't have a shoulder system.
There's a question in the chat about whether these animals would survive in aquaria at the surface, and the answer is from this depth, yes. So many of these crustaceans in particular, if we kept the water cold, and here the water's actually relatively warm compared to the deeper sea at 7 Celsius. So these could quite easily be kept alive and, say, on display in a public aquarium. Provided they were fed the right food. A lot of the really seep-associated creatures like clams or those tubeworms, we'd have to make sure they were provided with hydrogen sulfide. And that has been done as well. You bubble hydrogen sulfide into the water and the clams and tubeworms stay alive quite happily. SOI that the pressure doesn't seem to be a big factor at these relatively shallow depths, but once you get below 1,000 meters, it's very hard to keep animals from that depth alive once you bring them up. Don't take the crabs.
Is this a good spot?
Yes, perfect.
Yeah, try to get a good curve.
Yeah.
I'm not disturbed in that. Once you go, you
Maybe you just move a little. Yeah, that's good.
thrusting down.
And they're crust. You see that? Yep.
There you are. I think it's so. Let's just do that.
Pushing down, RVs moving up.
Okay.
That looks great.
You could stop and let's try and pull number 3. Have a look at it. Thanks, Levi. And we'll see if the microbiologists like it. It might fall, so don't worry about us getting an image of it. We'll just look at it as it comes, and you can put it straight into it.
Yeah, normally if you only this wet dry, it's gonna fall out.
It might fall out, yeah.
I'll
Okay.
try to go from the still position for it in a second. See this foot.
Okay, we can keep that for animals. Take it for animals. We'll take this one for animals. No, with coal.
Okay, yeah. Now next to the bacteria.
You don't want the internet?
It's too hard for the it's hard. Because I will find.
We're gonna have to move. This is not good. So we're gonna move. It's probably also wrong.
Oh, here. Okay, this is fine. It's okay.
You want 5 outside or in there? Outside. Okay.
Risk about open it out. This way. It's just gonna fall out if you sit here. Just do it.
So as long as just note that's a disturbed core, half a core, and use it for animals.
Okay, loosen your grip a little bit. Just a little bit. I'll regrip it once you have the pores happening.
this space because you got that big guy here. Some people don't just use one finger. Right, so they don't like it.
So we can check this one and then we'll go and look for a better map.
Greg, could we get a background cord just from the nearby sediment?
Right here. Just to the edge of this map.
It can be within a few meters. If you think
We
about
won't
it.
move. We'll try and
Yeah.
just reach out. Alright, Peter. I don't think these are useful for you.
Yeah, they might have some use, but it depends on how disturbed they are.
You're gonna get quite a lot of seepage activity a meter away, so are you sure you want your background cord to like a seep transition?
Sure, we go here.
Yes, normally you would go to a faraway process to take all the sediments here.
So this happens a lot when we didn't penetrate very far. So the core.
Great.
Yeah, let's keep it because it did fall in, so we could still sieve that. No problem. We'll use it for animals. So same logics. We'll just have this as an animal for the sieving. I think we should just move.
Yeah.
We're going to move and look for a site where we can call properly.
I was just, I mean, they want 3 background cores and 3 map cores. I was just suggesting don't do background with your map, because it's like a tone. Go pretty away. Loving wants 5 cores come together. As long as he's here, he can do it. So, no, I think he'd be okay with that. Let me ask you. You want your cores and microphone?
There's a lot of demand for cores, so we're just trying to strategize here. So we're going to move. We're sitting on a highly reflective area now that we've looked at the mapping, and
He just needs the bacteria so he can use the messed up there's Matt.
I figured we can see that.
Logio says take it next to Matt's, but wherever it's soft enough to get deep.
Let's head south project, and we'll keep looking for maps.
Do you want to go back on track?
I mean, that's always a trade-off.
We can follow our track.
Not all Matt's.
If we came up here, it's so good. And that's where we first saw the maps.
It's not where we are now.
Yes, please.
So the trick with this is
Do you have
the
enough sheets to actually use now?
methane results in this carbonate formation.
I'll bring you a pencil.
And so we want to be in that area, but we want not for there to be much carbonate, so we can actually sample the let's give this one a go.
To swim more? Yeah, to swim.
Can you settle there? You think you should push that card again? That'd be a better way.
Oh, there's another one.
Yeah, I see rock. There's rock right there. See, that's a rock. That might be a shell.
It's okay.
Yeah, let's go and have a look at this one. That we just for that. Have a look and see if there's rocks there that there are. Sit down and let's try.
Number 4. Should I do push first? Yeah. Yeah, we can run number 5.
The problem? Ah, yeah. Okay. Yeah, Yale, I already say this. I already say the first time. But if you want, when I see that is not a delicate situation, then I can, and there is a silent, I can say something else. Okay.
Do this one, right? Let's go here. No choice. So here we are at 412 meters off El Quisco, Chile, at a remarkable, reasonably shallow methane seep. And earlier today we've already seen lots of carbonate mounds generated by microbial activity on the methane. And away from the mounds we're seeing these bacterial mats. And so we're very keen to try and push for to get relatively deep sediment samples that can be sliced, and the water in the cores analysed for geochemistry, the microbial communities in the core to be analysed genetically, and potentially any animals living in the sediments of the core to be looked at. So we've got, ideally we'd like to get 12 more cores we could take. So we'll be trying to get a few here to work with these, but we've run into a problem with, not unusual problem, of having some carbonate underneath that's stopping the core from penetrating. So Levi's about to give it another go, see if we can get a bit better. No, we can. We looked at the last one. So that's It can be in white, please, then.
All white. Where are you talking? Just
Yeah, that.
maybe?
Yeah, right underneath you. That white and black is good.
That's kind of where I'm at.
Yeah, perfect. The two lasers you can see there are 10 centimeters apart, giving you a sense of scale. Looks like we've again hit the crust.
Yeah, that's not hard underneath, right?
Yeah, let's leave that in place, Doug, and try one more, and then we'll recover them both.
Yeah.
And let's yeah, do you want to try away from the white and black, maybe just where it's a bit more brown? Yeah, can we...
Closer to us?
Yeah, can you come a little closer? Just to the edge? Yeah, okay.
Just from range of motion.
Where you are is good. Hopefully the carbonate's not there. Yeah, that'll be good.
Okay.
That's my stop right there.
Okay.
I'll let that go.
Went in a little further, or?
It's about it right there.
Yeah.
Pretty good.
Okay. Let's go ahead and take 5. Oh, pull number 5. No, we'll just take the 2 here and then look for another spot. It looks good for Peter. That looks good for you, right?
I think so, yep.
So, do you want 3 from here, or is 2 good?
Working on that. I think if we have 2, that would be okay, and then 1 from nearby, that's not
Okay, so these 2 are for you. Very nice, thanks, Doug. Let's head a little more south and see if we can get another map. Let's try and get away from this rocky stuff. You want to try that? Yeah. Let's have a look at that. Oh, it's okay. Maybe we'll just go in, not over the blank, but just going to get to the rest. Yeah, I see rock here, so let's keep going. It's probably going to not be very good for us. test. And I thought they were happy with this, and they want it back. This is not far from this.
Yeah, that is okay.
So this is Sebastian Dive 726. It's just off the coast of Chile, a region called Quisco. Look it up on a map. It's a holiday town area for people from Santiago. And this is a methane seep that was discovered some time ago thanks to the activities of fishermen. And it's been characterized from samples that were caught from here, but has never been visited by an ROV. So we're the lucky first people to come and actually study this. And it's turned out to be pretty cool, so we've had a fun time today exploring. You can try this one. Yeah, thanks. We'll be going back later to some of the hard... Yeah.
We don't want to keep the white record outside the white record.
We will try in the white.
Yeah.
And yeah, because it's definitely microbial, but it's not as active as the last one. I'm hoping it won't be rocky underneath. So we'll be interested in characterizing the sediments here for all sorts of purposes, but also then the rocky areas. Hopefully towards the end of this dive we'll go back and sample from there, but first we need to get these push cores sampled. This one will get a bit of video before we sample. Thanks for that.
Wants to get a video.
Is it too bright? No, it's just too I think it's good. Yeah, I like it. Okay, that's good enough. Oh, okay. You see lots of filamentous bacteria. We've got a little shrimp hiding there. That's probably a mysid, a little whitish one gliding over. There's tubes sitting there that are probably dead Vesicomyid. And there are some gills coming out, which are the little amphoretid polychaetes. So this is similar to the previous more dense map that we've seen. So it's pretty active, and let's hope we can get some cores in here. Happy? Yes, that's happy. test anywhere where there's white, please, Doug? Oh, no thanks. They won't. It'll disturb the bacteria. Ooh, look at those bubbles. Nice. Great. Yes, please.
Geo?
Geo. Biota.
You wanna? Okay. 3? So do we want to put 3 here? Okay.
Where we want this one?
Just adjacent, thanks, Doug. And we'll try for 3. Yep.
There looks okay.
That's good.
Wow.
Yeah, one more, please. Just in the white edge there would be good, yeah.
Ready?
Yeah, that's good.
hard to break. Yeah, it's hard there.
Okay, is what it is. Maybe put another one in, Doug, over here, please. So you can see these cores are in what we call quivers. These are a relatively new design. I haven't seen it before, but you've seen bubbles coming out when we've done this coring, and we're at 400 meters here. So that's 40 atmospheres of pressure. So those bubbles would expand, if there's any bubbles in the core, dramatically on the way up, which is a risk of the core potentially blowing out of the catcher. So this design is designed to stop the core. Yeah, that looks good. Thank you. Okay. Sticking as well?
Yeah.
Okay. Lucky on the first two.
Hmm.
Yeah, go ahead. You weren't very settled down, were you? Do you want one more?
No, let's recover these. Thanks, Doug.
You want me to reposition it?
Hi to my people back in San Diego from my lab watching along. We got some cool worms earlier this morning, so I look forward to reporting back to you then later tonight. Oh, there's bubbles going into that.
ROV bridge.
Go ahead, Eric.
Are you guys happy for cover test deployment to the depth of 30 meters?
Roger that. We're good.
All right, you guys are happy. Thank you.
So I saw bubbles going into that core. So it's
Okay.
Fall out.
number 7.
Bubbling.
You can see the bubbles.
Mm-hmm. Yeah.
There's a big bubble of gas in the top of that core. which is definitely going to create trouble. As it comes up, it will expand dramatically.
Yeah, there's tons of bubbles in there. Hang on there.
Talk about the bubbles? You know it's a problem. This one's come up with less bubbles. Wow, they're still bubbling out of underneath. Look at that.